Good morning. Warm welcome to Day 2 of Global Road Infratech Summit and Expo, GRIS 2026. I'm your host, Anisha Nayyar Dhawan. I request all of you to please be seated. We are ready to start with our first session, which is the technical session 5. On the first day of the summit, we had power-packed presentations on sustainable infratech for India's Vision Zero, life cycle impact analysis, data-driven management of infrastructure assets, and a lot more. The theme of GRIS 2026 is Vision Zero India, integrating safety, sustainability, and technology in infra. Today, we will continue with the constructive dialogue on this important theme through pivotal discussions, presentations, and special addresses. Today, we'll be discussing climate-smart infrastructure, the future of mobility, and a lot more. We also have a concurrent expo, which is taking place as we speak. You can step outside the hall, move to your right, and you'll be at the expo. We have the expo exhibits also towards the left when you exit and go to the Samrat Hotel site. So do make sure that you visit the expo. Today is your last chance because the entire conference ends today. So make sure you go to the expo and you visit it to take a look at the latest trends and technologies which are available. So let's start with technical session 5, which is decarbonizing roads, building resilient and climate-smart infrastructure. Can we reimagine roads as climate-smart infrastructure instead of simple depreciating assets? How can India build road networks that are not only durable and inclusive, but also aligned with its climate goals and long-term development vision? Can embedding resilience and decarbonization into planning, design, and operations build a road network that is sustainable and safe for the future? Please welcome on stage our session chair, Mr. R.K. Pandey, advisor, Ministry of Road Transport and Highways. Please give him a round of applause and welcome him on stage. Mr. R.K. Pandey recently retired as member projects from the National Highways Authority of India. He has worked in various capacities in the Ministry of Road Transport and Highways and rose to the position of Chief Engineer in September 2011. He also served NHAI as Chief General Manager. I would like to invite on stage our speakers who will be making presentation. Please welcome on stage Richard Yeo. Please give him a round of applause and welcome him on stage. He'll be talking about resilient, safe, and decarbonized road infrastructure. Please welcome Ali Pinch. He will be talking about reducing Namibia's road carbon footprint. Please give a round of applause and welcome Ali on stage. Please welcome Vijeta Bezam. She will be giving a presentation on roadmap to climate and disaster resilient transportation in India. We have a presentation on bio-bitumen, a green solution for road construction, which will be given by Ambika Bail. I think Ambika is running a few minutes late. I will request our session chair to start with the session. Of course, the rapporteur for this session is Dr. S. Deepa of CSIR CRRI. And I request the chairperson to start the technical session, and we'll have Ambika join us when she comes.
Apart from Ambika, nobody else?
Yes, sir. These are the presenters we have.
So, good morning, everyone. I hope you can hear me clearly and loudly. So, very good morning, and I welcome you all in the 5th technical session of this seminar. Friends, decarbonization is a buzzword. As far as India is concerned, we are committed to net zero by 2070. Of course, when I say net zero, it is the commitment of the government by comprising all these sectors. But when we see the highway sector, in isolation we are doing a lot. We are modifying our specification. We are using those kinds of specification which gives us, moving towards the carbon neutrality. But as an action plan, if somebody asks me how much I am going to contribute in net zero, what will be my contribution in terms of the percentage, probably I am not in a position to say so. So today's event we are going to discuss, we can think of, and probably we'll be having some kind of, way forward how to achieve and what will be our contribution which I can go and commit before the government that this is the contribution from the road sector to achieve your net zero. This is what the objective is. So friends, we have 4 presentations during this session and we have around 1.5 hours. I'm keeping 10 minutes for me, 20 minutes for audience. So we have around 1 hour. So ground rule is each presentation, each presenter will give around 15 minutes. Okay. And the question answer will be followed after all the presentations are over. So shall I start with Mr. Richard Leo? You heard about Mr. Richard Leo yesterday. Since yesterday you are hearing. He is the COO of Netro and looking after mainly innovations. Richard is the chair of Australian chapter and vice president of Road Engineering Association of Asia and Australia and director of Indian Road Survey and Management, Netro, New Zealand. May I request Mr. Liu to take it forward?
Great. Thank you, Mr. Chair. It's my pleasure to join this event today in Delhi and come all the way from Melbourne, Australia, and see the audience a little bit thin, but I'm sure the video might be of use. So I'm from the National Transport Research Organisation in Australia, and we love to work around the world, and we have a joint venture company, Indian Road Survey Management, here in India. And I'd like to go through some of the topics that I thought were relevant to the conference theme today. A bit of background on the NTRO. We exist for innovation and we deliver solutions. So we love to work with academics and university institutes looking for those solutions, but then translating them into practice. And that's what we're about, is making a difference and providing solutions. We were founded in 1960 by the Transport Agencies of Australia and New Zealand as the Australian Road Research Board, and recently transitioned to cover a broader range of transport activities. We have a global network and we collaborate very closely with our colleagues in the UK, in the US, Germany, Sweden, and most recently with the CSIR, Central Road Research Institute, where we signed a Memorandum of Understanding just last year in September, and looking forward to working closely with CRRI to provide solutions in India. As I said, we expanded, our history was road research, but now we focus on transport research and broaden our scope, looking at road, rail, ports and airports solutions. And a lot of the knowledge that we've generated over the past 65 years is very relevant to these sectors. Some of the areas of expertise that we use or have are shown on this slide. Now, of course, yesterday there were some really interesting presentations and discussion around perhaps an inflection point of change, that we've been travelling along a path and then we've diverted. And of course, what we're seeing is a lot of change, particularly around climate events, adverse weather and natural disasters. I was thinking myself, it's not so much an inflection point perhaps from a global perspective, but it's a rate of change is changing rapidly. So we've always have change, and I don't think it's like a straight line inflection point, straight line. It's continuous change and rapidly accelerating change. And so we need to be able to respond to that, we need to adapt to that, and we need to prepare for that. And these are some of the topics that I'll talk about today. We certainly have no shortage of natural disasters, and particularly flooding events, cyclones, and of course bushfires. They impact us in Australia and across New Zealand, and so we're no strangers to these types of events. So what I'd like to talk about today is three topics. I'd like to talk about resilience, particularly resilience in the transport infrastructure. I'd like to talk about sustainability and decarbonisation as a combined theme. And also, I think the other third thing that's globally very top of mind, and particularly so in India, is transport safety. So just looking at resilience, I think one of the things we learned yesterday was, we build off historical understanding and how things progress, and then try and adapt to move forward to this changing environment. I suppose my third point here is the historical observations are insufficient. They actually may not well inform the future planning because the change is so fast, because things are becoming so extreme. So we need to be ready to address both the chronic changes, the things that we can observe, but also shock events that really test our system. We need to be prepared for both of those. So the frequency, magnitude and intensity of these events is getting worse. I'd like to start with resilience and some definitions around resilience in the transport sector. Some of the terms we talk about are durability, robustness, reliability, serviceability, adaptability and redundancy. These are all terms that are defined on the slide that form parts of our approach to resilience. And resilience is our ability to subsist under changing and challenging circumstances. Let's open that up a bit. In terms of resilience, you might consider three components. If you're planning for a resilient transport network, you need to look at criticality, vulnerability, and adaptation. Looking at these in turn, criticality relates to the level of service that we can provide, and it's that intersection between community safety, acceptable community service, the financial responsibility. We can only do so much within the financial constraints, and that was mentioned yesterday as well. And we need to undertake appropriate operations and maintenance. So not all the infrastructure is the same. So in resilience planning, we need to ensure that certain infrastructure is functional whatever the event is. There's other infrastructure that needs to be functional after an event, and then for some infrastructure, disruptions are tolerable, and in some cases, we just do the repairs later. And that sort of ties all that together. We can't do everything for all of the network all of the time. If we look at vulnerability, perhaps there's three areas here. We need to cover the range of likely, possible, and perfect storm events. So what could possibly go wrong? We need to look at reliability and uncertainty of our assessments. And this is where data and evidence we talked about yesterday, the data and evidence support the reliability and uncertainty that we understand our networks or we don't. We need to know that. And then how do we measure that and monitor these likely events? So that's the vulnerability assessment, and it's based on evidence. And then, of course, we can only go so far with resilience, so we need to adapt. So we need to plan to adapt our system for various scenarios. So establish warning and intervention limits, key risk indicators, and of course, we need to continuously update our thinking and our plan, and that's adaptation. So in a resilience plan for a transport network, we have to cover off all of these different topics as listed on the slide: governance, planning, design, construction, operation and maintenance, and disruption events. Now, a lot of these topics are covered by other speakers here, but I think that forms our approach to resilience in the transport system. And of course, NTRO is at the centre point of these resilience sort of thought processes and thinking, and then providing solutions across our networks where we work. And obviously we work closely here in India with our joint venture partners. And so looking at impact measurement, we're looking at measurement of the network. We do a lot of material science, and I'll come back to that. We can do risk assessments, and then we can do the planning. Part of the solutions that NTRO provides. Now moving on to the second topic of sustainability and decarbonisation, I think the best thing I heard yesterday was in procuring major infrastructure and road highway construction, the government of India has changed from tendering and appointing on a lowest price basis to appointing on a quality assessment. And sustainability to me is all about, that life cycle cost and minimising that and extending the life of the assets rather than, lowest price, build it cheap up front and then face problems down the track. That doesn't become sustainable. That's with current approaches, that's with virgin materials and scarce resources, making best use of those to achieve a sustainable outcome. And then the overlay of that is decarbonisation. So what alternative materials, what alternative approaches, what alternative resources might we then be able to deploy, and what risk profile do they have, what evidence do we have about how long they'll last. And so again, at the NTRO, we're very focused on this materials science. We have the National Reference Laboratory, and we undertake a lot of studies on existing materials and alternative materials, sustainable materials, and decarbonisation of the infrastructure build. And I know, again, I've seen a lot of the poster presentations. There's a lot happening in India in this front, and we like to be part of that community. Of course, in terms of decarbonisation, there's the infrastructure side and there's the operational side. So the second part of this is about the new energy vehicles and how we transition from burning fossil fuels to electric vehicles or hydrogen or other fuel sources. And this is quite challenging. One of the challenges we face, the technology exists. It's just how do we deploy it? How do we get it at scale? And we're in this dilemma in Australia because our network is quite fragile. We do actually control axle loads quite tightly with enforcement because we know if we overload our pavements, our infrastructure, it does not perform to its full life cycle. So one of the issues is if you convert a diesel engine to an electric powertrain, you have a large battery, particularly for long haul, and batteries weigh a lot. So they're increasing the tear mass. The weight of the truck is increased, and there's two options. We can either reduce the payload, well, the truck operators don't like that, impacts their profitability, or we maintain the payload, but we increase the loading on the infrastructure. So we're trying to understand what would that impact be, and how much would that impact change, and how do we mitigate for that? And that's a current issue for us to understand and gather the evidence that says you can maintain the payload, and of course everyone wants to increase payload for productivity, and what's the spin-off negative aspect for the infrastructure, for the bridge structures, for the pavements, and will we introduce greater wear if we do this, which then counteracts the sustainability and the longevity, and the life cycle costs go up. So we're doing quite a lot of work in this space now to find the optimal solution. How do we achieve this as we transition away from burning fossil fuels in our transport? And finally, to transport safety. I thought this sign was pretty cool out in the network. We wouldn't probably put the skull and crossbones in Australia, but transport safety is a major issue everywhere, and it continues to be so. And when we talked about yesterday 435 people, fatalities every day, that means today there's 435 people less in using the transport system, which is very sad. We have similar issues in Australia, and I was just discussing with my co-presenter earlier. We've got a very developed transport system. Our road system has been well established. We've done a lot of reactive work. We've done black spot programs. We've spent a lot of money improving our network and bringing it up to international standards. We've had major initiatives on safe system approach, international road assessment program and risk assessment, proactive safety treatments, and a lot of investment. And yet, when we look at the data on fatalities in particular, and serious injuries are the same, what we see in the last 30 years, in my career since 1990, we had this great transition downwards, this trend that said we're doing better. We've got increased road use, We've got more people out there, more vehicles, more transport, and we're improving safety incrementally, year on year, we're improving safety. And we set ourselves a target from 2020 to 2030 that we reduce fatalities by 50%. So our 2030 target is half what it was in 2020. And that was all looking good. But I'll just highlight the last 5 years. And it's turned, and it's consistent. I just put the figure in for 2025, and that last column is 2025, 1,230 or 1,260, I think, fatalities. So what we're doing is not working. What we set up 5-10 years ago with our approaches to safe system and proactive road safety is no longer appropriate and no longer giving us the benefits that we had seen in the previous decades. And we need to think again. And to me, it's about evidence. We need to understand what's happening, gather more data, more evidence, and that's what we talked about, evidence-based approaches. So one of the areas that we're promoting, and a number of other stakeholders are promoting, in Australia, if we have an air accident, a rail accident, there's an Australian Transport Safety Board that will do a thorough, no-blame investigation of what happened to understand and to avoid, to gather the data sets that inform those decisions. We don't do that systematically for road crashes. We don't do it for heavy vehicle crashes. We're advocating strongly that this is the sort of knowledge we need, the evidence that we need to better understand how to address this turnaround in these outcomes. So transport safety remains and is a growing issue, and I know it's a big issue here. It's definitely a big issue in our market in Australia. So we come back to resilience, sustainability, decarbonisation and transport safety, and I think where we're at is it's all about gathering the data and using the technology to gather better data, how we move forward and then make better decisions, evidence-based decisions to support our transport network, resilience, decarbonisation and safety. We have a whole fleet of vehicles. These are focused primarily on infrastructure measurement. We have a fleet of vehicles here in India. We're gathering data on the network every day, and increasingly so with better technologies. One of the world-leading technologies we have is this intelligent pavement assessment vehicle. It captures all of the data on one vehicle at highway speed. It's not an impediment to traffic. It flows with the traffic. It captures all the data that we need for the safety assessments, for the asset management assessments. And we look forward to bringing this technology here to India in the near future. And just finally, if I may, a case study. And this is just one of these dramatic events that hit the state. My state where I live is Victoria. It's in the southeast of Australia. And in 2022, there was a major flood event. Big rainstorm came across and flooded across about 1/3 of the state. 1/3 of the state went underwater at that time. And with our iPave, we had been collecting data on this network, 25,000 lane kilometres of highways for the state government. We'd been collecting that for 2 years in normal conditions in the dry. So 2021, 2022, we collected the whole state network condition and did an assessment on the resilience, I suppose, and the performance of that network, which enabled us then, after the flooding, after the water had subsided, to quickly go back and measure those roads that were impacted by this wet weather and flooding. Just to wrap up, we developed and we use a pavement condition index to interpret those massive data sets that we got into a simple decision support tool. And what we found was really, really interesting. It's sort of shown on this slide. The top bar in the red is, a 5-point scale. Very poor, average, and then good and very good. So in 2021, we looked at our whole network in Victoria, and the majority of it was average, 66% average. There was no very good sections of road, and there was 16% in very poor condition. Typical sort of network. Second year we came back in 2022, early in 22, we measured the same network, and they'd spent 500 million doing major upgrades. Interestingly, in Victoria, they generally use granular overlays to repair pavements. Granular overlays perhaps are not that resilient when it gets to flooding because they're not bound. They're unbound materials. Fairly low cost, very common. We've been doing it for 40 years. Life is good in early 2022. And we actually increased the very good part of the network to 3% with that investment, large investment. And of course, we got some good pavements, some very good pavements, and reduced the average. We didn't really touch the very poor pavements. 16% remained the same, and that's often the case. If it's already failed, there's not much point trying to repair it. You have to reconstruct. So if you've got some money, put it into the roads that need those low-cost treatments that will give them longer life. Wow. Then the flood came. And of course, our colleagues in our Victoria don't like me showing this chart, but the first thing that the Director General noticed, he said, "Where's my 3% very good?" After the flood, it was gone. All that funding they spent to repair the roads and improve them went to zero after the flood. It was not resilient, those treatments. And the very poor, you can see from 16% to 42%, we had a problem. And so it was quite a large repair bill, and I suppose it just demonstrates the value of the evidence and data and the need for more resilient use of treatments, more resilient materials, and different thinking. What we had been doing for 40 years, these types of treatments, no longer works when the massive events come. So that was just a bit of a case study, but a lot of insight we can gather by having really good data sets, consistent data sets year on year, and that's sort of where we're at here in India, that's where we're at in Australia. So thank you very much.
Thank you, Richard. Our next speaker is Mr. Ali Impinge. So, Mr. Ali, he is CEO of Namibian Road Fund Administration. He is on the board and executive committee member of International Road Federation. He is the past president of African Road Maintenance Fund Association, and he is also responsible for bringing PPP in the country. He has vast experience in the field of corporate and commercial finance, financial management. I request Mr. Ali to take it forward.
Thank you. Thank you, Session Chair. It's good to be here in this bustling city of New Delhi. It's my second visit under a year, and every time I come, I'm quite impressed with the developments that are taking place. I am from Namibia. It's a big country in size and smaller in population, and that gives you a context of my presentation in terms of some of the challenges that we are experiencing in terms of climate change and how we then adapt to some of the new technologies and systems that enable us to become more resilient. There's a lot of talk about Africa and the opportunities and, of course, challenges. But just to remind the audience that Africa is not a country. Africa is a large continent. In fact, it's the second largest continent in the globe and carries about 20% of the global population. So you can see that is a diverse continent, diverse cultures, diverse interests. But certainly if you zoom in on specific areas and regions, that's where, in my view, opportunities lie in terms of investments, in trade, in tourism, in infrastructure, transport, ports, rail, health, etc. So there's a lot of opportunities that exist on the continent. And I'm sure in terms of the future, it is bright, and certainly as an African, I then encourage, of course, those entities, companies that are interested in investing in Africa, but more so I'm a Namibian, and I'm looking certainly, as we expand our economy, we're also looking at investment opportunities coming into Namibia. I manage the Road Fund Administration. It's a state-owned organization that provides road financing and funding for Namibia. And I'm going to talk about some of our experiences that we have gone through in addressing some of the carbon emission issues, particularly in the road sector. In Namibia, and certainly in the subcontinent of Africa, we call it Southern African Development Community. It's much lower on the subcontinent. Roads in essence, carries about 80% of passenger and freight, both in Namibia, but also I think that cut across Southern Africa. It's something certainly that we are not happy with. We need to move to other modes of transport, rail, air, ports, so that we can diversify how we move and carry passengers and then goods. We are primarily a mining country. Mining is one of our largest sector in the economy, from uranium to diamonds to gold and other minerals. And certainly what we are seeing is that most of these commodities are transported on the road. And again, we need to find a way how we then diversify the movement of those goods more to rail. And certainly in our country, roads sector carries a major or contribute actually greatly to carbon emissions. And then we have then, as part of our efforts, to see how do we then ensure that we mitigate these challenges through material production and how we produce materials and how we import these materials for roads construction, the method of construction and the method of maintenance of our roads, but also how it impacts on the vehicle operating costs and the emissions by the road users. I think the question is no longer whether climate change is real, but I think it's a question, how do we mitigate the impact of climate change in the transport sector? And certainly what we are seeing, Namibia is a drier country. Part of it is a desert, but also some part is more subtropical. But we are seeing with incremental weather, on the upside, we are seeing cycles of heavy rains and a lot of wash away that comes with it. But also some cycles brings prolonged drought. And again, we have, the heat in summer is become intense in some areas up to 40%, but also during our winter, the temperature drops to below zero. So again, we need to find a way, how do we then ensure that the way we design, the way we construct, and the way we maintain our road asset addresses those issues. And I think this then brings me to the conversation around the life cycle assessment framework. And I think Richard spoke to some of those issues in his presentation. But from our side, we have done some of these assessments to enable us to become more resilient in terms of how we deal with the road design, how we deal with construction methods, and also how we then maintain the road asset. The life cycle assessment as a concept, it really evaluates emission across the materials that we use in road construction, the construction method, and then also the maintenance and the end of life cycle of the road. And it also identifies high impact mitigation opportunities, and it also enables better planning and including design and procurement. And then I think this for us is an important tool that will help us in a way. It's still a new framework, but we are, of course, going to, as we go on, perfect that system to then ensure that we have a better, resilient, and sustainable road sector for the future. Now, in terms of the mitigation technology, I think Richard spoke about some of these details in terms of how we then electrify and automate some of the assets that are used in road construction. We have seen, particularly in the mining sector, there's a huge investment, as I said earlier on, in the mining sector. They have actually moved a step further in terms of the mining equipment that they use, that they don't only rely on diesel, but we have seen that they are using hydrogen, they are using gas, and also electricity or electric machinery to enable them, of course, to become more efficient, but also to reduce carbon emission. And I believe that those kind of technology can be scaled up in the road sector. And certainly, in our view, will lead to some emissions. And I think the projections are that, between 20 to 40% through these pilot projects in the mining and in some part of the road sector in Namibia can reduce significantly the emissions in terms of the equipment. But also, digitalization is important. We have to bring in the technology to enable us to become more efficient. And certainly, technology costs money, but we need to ensure that we invest in appropriate technology to support the road sector of the future. In terms of the material, we are looking at how do we then become efficient and introduce better low-carbon materials. We have seen in South Africa, for instance, they start to recycle some of the materials on the roads. If you are doing a rehabilitation, instead of cutting away, these asphalt or bitumen, you find a way to recycle this and reuse in the same road as you rehabilitate same. And we believe that, if we do that efficiently, there will be a net reduction in carbon, and I think that is a future that we want to see of better, and I think the concept is, of course, net zero emission. But over time, if we implement some of these methodologies and technology, will lead to better carbon reduction. Now, I've spoken briefly about some of the case studies for Namibia and some of our neighboring countries, in that we have seen that with better climate resilient pavement design and also using modified material production on our roads has led to some good reduction in carbon emission, and then also better preservation of our road asset. South Africa has actually gone further, and in terms of their regulation and legislation, they have introduced green procurement in the road sector, where if you introduce better technology, appropriate material in your proposal as a contractor, for instance, you get additional points in terms of your green procurement. And that, I think, allows the diversification of the construction method that will then improve on your sustainability. And then also we have seen that they do a lot of recycling, also using alternative materials in terms of their road construction. Botswana and Zambia, we have also seen that they are slowly introducing the new design guidelines in their construction method, which we believe will then eventually lead to better cost management and increase durability of our roads. And I believe that with the improved pavement life and reduced emissions, it can only help with the better maintenance and also the frequencies we believe that reduces if in your design and also in your construction you bring this up front. We are also seeing that the vehicle operating costs for the road users that we then serve reduces with better quality roads that are more sustainable, and the long-term emission reduction becomes, I think, the expectation through this effort. Now, from a policy point of view, what we are seeing is that if you come up with concrete policy interventions coupled with better financing tools, will become, I think, a better enabler for our climate resilient roads and response. And I think these standards, in our view, needs to be embedded in the policy framework. Of course, it has worked for us, but I believe it can be scaled up on other parts of the globe as well. I've spoken about the green procurement initiatives to incentivize contractors and engineers to evaluate those proposals that are more green in nature. Then that will then, of course, lead to, I think, better procurement outcomes at the design phase. And what we're also trying to employ is in that I think if you come up with these policy initiatives, certainly your governments and your state regulators might provide more financial incentives to the sector that then allow for better and futuristic sustainable roads for the future. There are, of course, also on the global scale, there's a climate fund that I think the UN and a number of developed countries are pushing. I think these are also opportunities for countries to undertake. If you have got, of course, the policy instruments in place, there are then this funding that are available in the market for the road authorities and road agencies to tap into. Now, in terms of the strategic roadmap, in our view, for us to achieve low carbon emissions, there has to be a strategic roadmap across our countries, both short-term in terms of the policy framework, but also on the long term, we have to see how do we then drive this agenda on a continental basis or on regional basis to ensure that there are alignment across the various countries on the African continent specifically, but I'm sure this can be replicated elsewhere. Now, in conclusion, the low carbon and climate resilient roads are achievable and are certainly necessary if we have to sustain our roads for the future, given, of course, the impact and the effect of climate change. The life cycle assessment and actions are important, and we have to, of course, come up with relevant policies and instruments that enable the scaling up of these actions and programs. In terms of the African continent, we have the Agenda 2063 that pushes for better transport programs and then better transport outcomes for the continent, where we want to link this large continent in terms of road transport, but also other modes of transport on the continent. So that was my short say, Mr. Chair, and I will invite for some questions later. Thank you.
Thank you very much, Mr. Ali. Now our next speaker is Ms. Vijeta Bejam. She is Senior Transport Specialist from World Bank and did her post-graduation in Civil Engineering for Risk Mitigation from Italy. She is World Bank Senior Transport Specialist and Climate Resilient Focal Point at World Bank. And she will be talking to us on roadmap for climate change and decarbonization for India. I request Vijeta to present her.
Thank you, sir. The presentation is not on. Yeah, press no. So, good morning, everyone. My name is Vijeta Bejam. I'm the Senior Transport Specialist from the World Bank. And today we will be discussing on the roadmap to climate and disaster resilient transportation towards sustainable infrastructure, road infrastructure in India. So the speakers before me, they have covered a lot of points that I have to cover in my presentation, but let's see in the Indian perspective, what is the roadmap towards resilience. So it's not working. Our goal is to build awareness around the challenges and strategies to enhance the resilience of communities and businesses through sustainable transport infrastructure systems and services through all the subsectors of transportation. So climate change and disasters are more evident than ever. So what is at stake? So the transport infrastructure is getting severely impacted, causing huge economic losses. So the global disaster impact studies have shown that 27% of roads and railways are actually affected by at least one hazard. And the studies also says the financial losses in 2021 due to disaster events in Asia amounted to about $35 billion USD, and out of which 80% is caused by floods and storms. So let's understand what is the socio-economic impacts in South Asia region. So the economic losses in the South Asia region due to climate change by 2050 would be minus 1.8% of GDP. And 800 million people are already living in the vulnerable locations in South Asia region. And the transport infrastructure losses per year globally is 15 billion USD. And if we do not do anything right now, then we will have 23 times compounding effect on the cost of disruption. So the socio-economic impacts in India, we can see the severity, the 30 to 40% of our road network is actually exposed to the flooding. And the flood losses in the last 20 years, you can see that the people that are killed or affected are more than 370 million. And also the damage caused was around 45 million USD. So why resilience is so critical in India? So under the union budget, we usually, every year we get a budget under the NIP, which shows that, that 40,000 projects for the transport sector has been released, and it is amounting around 1.5 trillion USD. So if you see, the roads and bridges are at high number, so the resilience of all this infrastructure is not accounted for. So in that situation, it is very essential and it is critical that we have to include the resilience cost into our infrastructure. So we also have some gaps in the country system, like the policy and legislation framework has gaps, and the design and implementation has potential to improve, and research and technology standards are weak. And we can enhance them furthermore. The asset management systems and maintenance is very limited to certain states, and the institutional structure and capacity is poor, and there is a lot of major gaps in climate financing and also community preparedness. So what are the ongoing efforts in India towards adaptation? If you see the NDC, we see a major shift is towards mitigation, which is 85%, and towards adaptation, it is less than 15%. I think it should be equal because both go hand in hand, and adaptation also has to reach to 50%. And even the climate change agreement speaks about the same, that both the mitigation and adaptation has to be equally treated. So what is the World Bank supports towards adaptation? So the World Bank statement for adaptation says that each lending project has to have 45% allocated for mitigation and adaptation. And out of 45%, 50% should be accounted for climate adaptation. So we are also collaborating with CDRI. CDRI is Coalition for Disaster Resilient Infrastructure. It's an entity established under PMO office. And this particular agency has the role of improving the resilience to the infrastructure in India. So we are focusing on the transportation with them, and we are collaborating on topics like strategic roadmaps and policy influence, capacity building and knowledge exchange, risk assessment and digital tools, joint events and global advocacy, and knowledge products and publications. By doing all of this, the gaps that I have shown you earlier, we are trying to fill those gaps. So what is the World Bank's approach to resilience? This is the 5-pillar resilience approach that bank takes during their ongoing projects. So first is network planning, which Richard has clearly explained us, that we have to do a risk assessment and then see if the new development is falling into high risky zones, then we have to avoid constructions in those zones, or we have to increase the cost of the construction by including the resilience. So the second pillar is design and engineering, which is you have to put the resilience components into your design and then you have to implement them. The third pillar is operations and maintenance, where you will operate to get better revenues, and also you maintain your asset in such a way that it will take the impact of the next upcoming disasters. And then we have fourth pillar, emergency planning, which is traffic management, emergency planning, and traffic evacuation plannings, which is very poor in India. And there is fifth pillar, which is cross-cutting all these 5 pillars, is institutional and financial capacity. So this 5-pillar resilience is also further divided into 2 parts. One is resilience of the asset. So transport asset resilience, by doing the proper designing and also proper implementation, we can achieve this. And we have resilience through community resilience, which is called community resilience. So when you take care of the design, the network planning, operation maintenance, and emergency planning, we are actually tackling the community resilience. So we have done a gap analysis in 2021 survey where the sample size was 18 states, and we have consulted ministry level, state level, and local level departments, transport departments and PWDs. So we have seen that under all these 5 pillars, we have given them some questions to answer. And based on those questions, we see that there is a huge gap in understanding resilience and incorporating resilience into the system. So at least the first 3 pillars are 40%. We can say it's okay and we can improve them. But we have a lot of concern on the other 2 pillars, which is less than 20%. So how are we addressing these gaps? So we are tackling this resilience under our World Bank ongoing projects in different methods. So let's say, okay, this is the map where you can see the pink points shows you the ongoing projects, and we have the past projects like PMGSY, EDFC Railways, and also we have pipeline projects, which is Assam Disaster Hill Roads recently got approved. So all these projects, we include the resilience in the design and implementation. We are also preparing policies like climate adaptation policies, and we are also working on various development of early warning systems and also resilient infrastructure. So these are some of the best practices that the bank has taken up. So for the slope protection measures, we have used gabion walls, breast walls, toe walls, and bioengineering solutions for slope protections, which are short retaining or hydro seeding, etc. Then we have used the green fascia for retaining walls, CTSB methods, and also heat-resistant roads. And we also incorporated the resilience in the structures like major minor bridges, culverts, and drainage systems. And we have also started enhancing resilience in India by spreading awareness since last 6 years. So from 2021 onwards, we were doing multiple webinars, seminars, conferences, writing blogs, creating a pool of government officials and also the contractors, supervisors, where we gave them the knowledge by showing them the exact site locations, how these resilience has been incorporated. So to conclude, I would say that we have to act now to avoid the 23 times disruption cost and also improve transport asset resilience and enable community resilience. So these are some of the resources in the bank. We have climate change action plans for 2021 to 25, and now the latest one will be coming out soon. And we have upcoming a CCDR, which is country climate and development reports. And so to conclude, I would say let's together build resilient transport infrastructure and resilient communities. Thank you so much.
Thank you, Vijeta. Our last speaker, she has entered the hotel, but anyway, she may be joining us another 2-3 minutes. In the meantime, we have adequate time, and I expect whatever question you have from the first 3 presentation, please raise your hand. And any question from this row, first row, right side?
Hi Richard, I'm Tony Matthew from TRL. My question is, in Australia, you have a lot of existing paved road network, right? So is there any different, so obviously a large part of Australian network is also affected by hazards and all. And there is this overall policy of improving climate resilience of the network. So is there any difference on the maintenance practices now compared to what was done in the past to make the existing network more resilient key some of the, is there any significant difference on the existing practices, on the new practices?
Okay, yeah, no, very good. Thank you for the question. And absolutely, yes. I would contrast, I was just reflecting, in the case study I talked about my state of Victoria, and Victoria's climate is not as extreme as perhaps other states. The other state I'm thinking is in the north, Queensland. Queensland has annual major flood events. They have cyclones, they have extreme weather, much more than perhaps in the south. And because of this, they understand and have understood for several decades the need to respond and to be resilient. They have a very close relationship with the National Transport Research Organisation. We work very closely together to develop evidence-based solutions that are more resilient, and then they implement. So in their maintenance practices, they have been using a lot of foam bitumen stabilisation treatments on the existing granular pavements. Victoria has not yet used this treatment, but Queensland's been using it for more than 15 years. They're looking at much higher percentages of reclaimed asphalt pavement. They're looking at all sorts of material science solutions to build resilience into their maintenance practices. And they collect, they've been collecting IPAVE data since 2014, network-wide, to understand the performance of their treatments over time and that whole of life cycle costing, so they can justify the investment in the resilient treatments. So their network is far more resilient and experiences much more flooding than perhaps in Victoria. And when Victoria was hit, it was not ready. And they haven't done the research and they haven't tried the treatments. So it does vary depending on the approach. If you plan and design and validate, then you can implement a more resilient system. And it does take evidence and does take innovation and research, such as what TRL does and what we do at NTRO. And I think that's a great example of an outcome of using the evidence and science to get a better outcome at a statewide level.
Thank you. So anyway, the last presenter she's here. So we'll take it forward and thereafter we'll have question answer if any question is there. So Ambika, you have around 15 minutes, and Ambika, she is well known. She is from CRRI, and she will be talking to us on biobitumen.
Okay. Good morning, everyone. First of all, apologies that I am late, but Delhi's traffic, I'm so sorry. So today I would be talking about a research initiative which CRRI took almost 5-6 years back. And we started working on the alternatives for petroleum bitumen. We all know that bitumen is a petroleum product. And we as a country, India is highly dependent on other nations for giving us crude oil so that we can produce this bitumen. And Krishi Bind is the trade name. So the topic of the presentation is Krishi Bind. That is the trade name we have given to this product. And we launched it on 7th of January, and 14 industries were given the license to start producing biobitumen. So if we talk about what actually is biobitumen, so there are a number of ways the research across the world is going about how to have alternatives for bitumen. So there are ways to produce it from agricultural biomass. So the yellow ones are on which CRRI has already developed the product. We have a lignin based with Praj Industries biobitumen, and then from rice straw by the process of pyrolysis. So there are different ways by which we can produce from waste materials, from algae, from waste cooking oil. So it's basically replacing your crude petroleum bitumen in different percentages. And right now we are working on wood chips, cashew nut shells, as well as Juliflora cotton stalk in another MORTH-funded project. So we are trying to produce the same biobitumen from 4 of the other sources as well. And how we treat these waste sources depends upon there are different processes, like you have thermal pyrolysis, you have liquefaction, you have free radical polymerization, lignin, bioethanol. So there are various number of ways to do that. when we started working on this, we knew that there are some researches going on in various parts of the world, and people are like replacing 5%, 6%, some percentages are being replaced. But we at CRRI thought was that we wanted to produce something which has exactly similar chemical structure, physical properties like a petroleum bitumen, and we do not aim to replace some 5-6%. We wanted to have a big chunk of petroleum bitumen replaced by the biobitumen. So we started our research on lignin base and rice straw pyrolysis. One can choose out of all these number of ways, but it all depends upon the availability of your biomass and what process you want to adopt, and then each and every process will give you different properties in the end bio oil. You know, like if I go for simply a liquefaction process, maybe I will be having a bio oil which will be very, very low in molecular weight. It will be having very high oxygenated compounds, which will lead to very high aging in the bitumen. Whereas if we go for polymerization and pyrolysis, then I will be having something which will be having high molecular weight in comparison to biobitumen. So it all depends upon what is my target product and what I want to make out of that waste. So it all started from the initiation of that what the problem India as a country we were having. That yes, out of our total bitumen which is being used for road construction, 50% approximately of that is being imported. And this import cost is a huge burden on the country, which is approximately 25,000 crores. Each year, India imports bitumen. So we got a task from Road Transport Ministry that if CRRI can come out with something which can reduce this import burden. But at the same time, we thought that we can hit another problem, that if we target, those days it was too much that every year in the month of November, Delhi hits the high pollution zone, the AQIs are very, very high, and people started talking about the burning of parali. We all know rice straw. So we thought, okay, let's do work on this as well. If I have to produce a biomass, let's target the rice straw itself. So we joined hands with our sister laboratory, Indian Institute of Petroleum, because they are the masters in producing biofuels. So we did a joint project with IIP, and we started working on pyrolysis. We had n number of samples coming in different properties of oil. But then, of course, after a year or two, we could hit to that combination, that recipe, which can actually replicate with my petroleum bitumen. So this is the scenario that so much every year, the red spots are the places where the crop burning takes place in the month of November and October. So it's really, really polluting. So we thought of tackling dual problem with one solution. And the solution was our biobitumen. So as I said that we did this in a joint research with Indian Institute of Petroleum, filed a patent as well, and it's basically a pyrolysis process. So after getting an oil from the pyrolysis, we did further distillation, and then the fractionation, and then we did the radical polymerization so that it can have high molecular weight and viscosity, something similar to my petroleum bitumen, and that's how we could reach up to 30% of the replacement. So my laboratory trials shows that I can replace till 30% of the petroleum bitumen, and in field we have done a trial of 10% and 15%. So basically, it's basically, India as a country has always say that recently it's in news as well that why only this agricultural waste we targeted in this, because India, if you see, is a very, one of the largest agricultural producer. So we wanted to, we at CRRI wanted to, choose such a resource which is the power of India, that we are an agricultural based country, and produce bitumen from that. So it's of course, but then the challenge was that there is a huge variability. All of us who are working in this biobitumen research area, there is a huge variability. Like if I'm producing biobitumen from rice straw, the properties will be different. If I'm producing from cashew nut shell, it will be altogether different. If I'm producing it from cotton stalk, it will be different. The difference will be in the chemical composition, in the molecular weight, and in the end in the viscosity. And that is what is matter in bitumen for road construction. So one needs to very carefully understand the spatio-temporal patterns of all these producers. So what we have done is we have come out with the basic properties that this is what we want from bio-oil. So whatever agricultural waste anybody in the country is going to use, they have to reach to these properties. Now how you reach, it depends upon different processes, and then people are having patents on all those processes. So what our process tells us that once I take the rice straw from the field, the process is that we pelletize it. After pelletizing it, I have to do the pyrolysis at very high temperature, approximately 450 to 500 degree centigrades. And after I do the pyrolysis of these pellets, what I get is 30% of the biogas, 30% biochar, and 35% then bio-oil. So these are different variations in which I would be getting. So now another task was that if I see only on bio-oil production and I ignore biochar and biogas, my process will not be economical. So we have to see these two streams as well. And if we are giving this process to the industries that, okay, you start producing bio-oil, which can give you biobitumen, but in the end of the day, they will be landing with huge amount of biogas and biochar as well. So we started working on that. We gave them the process for biochar as well, in collaboration with IIP, that they can use the same biochar can be given to the graphite industries. Hard carbon can be produced, which can then go for the ion batteries. And biogas can be then used to run the same plant. So it's like we are making biogas as the running fuel for the plant itself. So we tried to economize all this process, and what we landed at this, that my biobitumen would be cheaper than the petroleum bitumen, having the similar properties. This only can happen if I consider all the complete product streams has to be used. So bio-oil, as I said, that's any bio-oil cannot be used. People are these days, so many people are coming to CRI, they think that we have this bio-oil, madam, give us the certificate to be used it in road construction, but then every bio-oil cannot be used. One has to modify that bio-oil so that your end product will have properties, as I said, similar to bitumen, petroleum bitumen. So what we did is, after having that bio-oil in CRI, we did a lot of combinations. We tried liquefaction, we tried polymerization, we tried adding the fillers as well, like jigget as well, and finally we reached at a recipe which gave me good laboratory results. We studied the rheological properties, physical properties, chemical structure of that biobitumen, then the performance characteristics in terms of moisture stripping test, and in terms of wheel rutting, cracking, that how this bitumen is going to behave in comparison to conventional bitumen. And after we got the good performance results in laboratory, we went ahead with the field trial. And yes, so if you can see here that the biobitumen, in which it is 30% replaced. So our target was to have all these SARA components in the same range. So when I am getting my aromatics, asphaltenes, saturates, resins in similar composition of bitumen, it is tending to behave in the same way as my conventional bitumen behaves. So the composition we could achieve is almost similar. And then with relative to the physical properties, that how is my softening point. So we tried different compositions, 10%, 20%, 30% in the base bitumen with the help of the hard pitch. And only if I am improving the properties of the bio. So all these processes have different then economics attached to this. But then we could reach to a final recipe which gave me properties. But then the issue started coming was, because of high oxygenated compounds, it was giving me aging, early aging in comparison to the petroleum bitumen. Then again, we worked on with some additives. We added those additives and we could control the aging. Then again, the complete performance evaluation in laboratory was carried out. And after having the confirmed results in laboratory, we carried out the field evaluation. So a number of samples were tested. It was almost 1 year we took in performance characterization with different compositions. And you can see that in terms of dry ITS, wet ITS, tensile strength ratio. So the properties are in line with what I'm getting with the conventional bituminous mix. We also did the stripping test, and which is the boil test, and I'm only showing one slide, but we did like 10 minutes, 30 minutes, 1 hour, 2 hours, 3 hours, 4 hours, different times also. We checked that how much is its resistance to, it can hold the coating in that temperature. And we found that it is giving results equivalent to the conventional VG40 bitumen. And these days we have enhanced this research for polymer modified bitumen as well, that we can have polymer modified biobitumen. And we also did the indirect tensile fatigue test, and I could see, that my biobitumen samples could sustain more cycles, little more cycles than the conventional bitumen because of all those additives which we have added. Yes, this project was, this slide is just to show that it's a long journey. So we started this when R.K. Pandey sir was in NHAI, the member. He helped us a lot in this project. And now when we are finishing it, we are almost finished and took another project when Rajavarji is there in Morth, and we have really getting good support from both NHI and Morth. So Dr. Parida was there in CRRI when we started this project, and now when in the finishing leg, Dr. Ravi Shekhar is our director. So it's a long, long journey, 5-6 years we gave to this project, and we happy to share that yes, we could reach to this stage, that we could have the first trial section as well. And after we were given the target by Morth that if it lives for 1 year, then we will give you another project and some more sections. So yes, this section could live for 1 year, and then now we are getting more and more projects, more trial sections, more funding from Morth to carry out this project. So it has many, many benefits. Not only that we are reducing the import cost of bitumen, so recently we have given it to the government, and it was discussed in this session as well, that let's start with 10% replacement. So though our technology says that we can have 30%, so even if I start with 10 to 15% replacement of petroleum bitumen, our country can save almost 4,000 crores annually just by reducing that import of conventional bitumen. At the same time, of course, it has almost the, if I compare the petroleum bitumen production with the biobitumen production, my carbon emissions are very, very less, almost 60% less than the petroleum bitumen. And at the same time, we are improving, if largely all these states adopt this and we stop the crop burning, we can tackle the environment pollution. And at the same time, it is a very, it's such a technology which can benefit farmers as well. So as on date, farmers are just burning it, but when we did the complete process calculations, a farmer can get 9 rupees per kg for that pellet, which can be used. So the thing which he was just simply burning, now it will empower the farmer also, that it can be a part of this complete supply chain. And yes, these are the benefits. As I said, on 7th, we transferred it to 14 companies, and the first plant probably would be installed by March. And then the 13 more companies are there, and said I'm happy to share that we have got 15 more requests. So probably by February end, we will be transferring to 15 more companies. So we are having more and more people who want to join this and want to help the nation in cutting down on imports. So these are those 14 companies in the different parts of the country who have already taken this technology. Some of the references, our papers, and yes, just to show that recognitions, we got Build India Infra Award, some Best Technology Award, IRF also in the Turkey conference. We were the second in line for the Best Technology Award. With this, I would like to end my presentation. Thank you.
Thank you. Thank you very much, Ambika. Now, floor is again open for question. Any clarification, any question from the floor side? Anyone? Yeah.
Good morning to all. I'm Karan Randhawa. I come from Border Roads Organization. My question is to Dr. Vijeta, if I may. We talk about roadmap to climate and disaster resilient transportation, but we have been seeing from last at least 3-4 years that entire Himalayan region, if you start from J&K, Himachal, Uttarakhand, is very, very getting prone to disasters. So my question is, are we doing it right? Are we failing at design level or execution level? Why are our road infrastructure not getting better and causing us problem? We are into four lanes, expressways, but somewhere we are doing something wrong. Can you just throw some light on that? And if a government is onto it?
Yes, thank you for this question. It's really a good question. Um, as I was mentioning in my slides also, there are gaps in the country systems. So we do not have a policy that resilience has to be incorporated or inbuilt into the system. Similarly, we don't have the designers, DPR designers, and also the contractors who understands the resilience well. So we have gaps in those areas as well. So similarly, in the capacity of emergency responses or emergency rescue, we have still gaps in terms of transportation. So what I have observed in over last 6 years being with the World Bank, that we are trying to influence and change this culture of not understanding what resilience, and we actually brought in the resilience into our ongoing projects. But our fraction of projects are very less compared to the entire India. So we are doing only, let's say, 5% of the projects in India, and we are making sure that the resilience at all 5 levels, at the 5 pillars levels that I have mentioned, are incorporated. But the question that you're asking, why the government, what does the government doing? So I can say that government is literally interested in going towards resilience, developing the resilient infrastructure. So the DEA, the Ministry of Finance, also has started to actually do a risk screening for all the projects. So 40,000 projects that I was mentioning under the NIP, they are getting screened. And once they get screened, they will get a rough figure of amount which will be extra cost for the resilience. Once that is clear, we will have enough money in order to implement the resilience into the designs and also implement them on the roads. But for this, we need a lot of support from the government and also from the political parties. And I agree that Himachal and Uttarakhand and also some of the Assam areas, they are flooded, they have a lot of landslides. And this has been tackled slowly from engineering point of view, but I think it is also necessary that we have to educate the community to become more resilient. So yes, government is taking steps, but those might not be seen as major steps, but slowly, I think we will be there in becoming resilient India. Thank you.
Thank you, ma'am.
Any other question?
So my question is to you. Is there any Australian, based on your study on the asset management and the things you do on the survey others, do you find any way where road infrastructure, the asset management also leads to saving in the carbon or decarbonization as well as safety, both? Currently, they're all competing each other and we honestly incur the extra cost. Is it a way which combines all these three, the asset management leading to a safer ecosystem and the decarbonization put together? Is any technology, any study which you have done? And second question to Ambika ma'am, to you. Let's say we scale biobitumen. Then what do you think, what will be the net carbon saving? Any analysis or study you did? You said, say 20% will be replaced or some 5 lakh. So how much carbon saving in the road infrastructure ecosystem we may likely to get?
Okay, thank you. Very interesting question, and I think it's a big challenge to bring together different concepts. So if we talk about decarbonisation, sustainability, resilience, and talk about safety, they're often different departments, different individuals involved. I know we do a lot of major programs for road safety improvements, and ideally they fit within the asset management framework and they're targeted and they align with other infrastructure upgrades and maintenance, but commonly it's not done. The decarbonisation initiatives need to be brought to light, and it's really the whole of life cycle assessments that enable them to be cost effective and to be justified. And we've developed some interesting software tools to incorporate all of the knowledge we have, the materials science knowledge, into a life cycle evaluation. So you can do conventional materials versus recycled materials and calculate energy use, and calculate emissions, and then compare them and look at options when you're doing maintenance strategies. And these tools, they've been developed, but implementation is now a challenge. Getting people to adopt them. We have a little bit, I mean, we're a state-based country. We have a national government, a federal government, and sometimes there's a lack of leadership to have national approaches, and we don't have a carbon price, so it actually makes it harder to then implement lower carbon solutions when the cost pressures are on. But we are very much focused on trying to have the tools available. When leadership occurs, we can then do the analysis, and it's a life cycle based analysis. And obviously trying to combine those safety considerations into those investments as the maintenance is done. But as I say, it's a challenge. We have the science, it's just about implementation, I suppose, and leadership.
Thank you.
Sir, as I said that when we only compared the process of crude oil distillation and my pyrolysis process to produce two things, it came out that production of biobitumen gives me almost 60% less carbon emissions, because crude distillation is a very carbon rich process. I mean, emits carbon a lot. But when you say the complete life cycle, because we have yet to do that now, when the production will start, what is my lead distance, what is the complete process of transferring there, and then again blending at the hot mix plant in large quantities, and then the process of pelletizing at a large scale. So the complete life cycle analysis in terms of carbon is yet to be done, and that's what is the one of the objective of our MORTH funded project. So we'll be doing that. As of date, we have compared only the basic processes. Yes.
Any other question? Then with this, we come to the end of this technical session. Friend, during this particular session, we had 4 excellent presentations. The whole idea is we heard about how around the world decarbonization has been achieved. In fact, if I see in a nutshell, short term, long term, or medium term, whatever you call it, people started using, less emission vehicles for construction, started using low carbon emission material for construction. All those, in fact, in India, even also we are doing it. Even for low carbon emission materials, standards are available, IRC specifications are available. If you see the warm mix, recycling, even cement treated base sub-bases, all these are available. What I was looking for, how to, bring those kind of policy which will encourage to use of all these material. Today, all those technologies which are cheaper in terms of money are being used by the industry. But no way we are in a position to compensate the technology which is little costlier, but in terms of decarbonization or in terms of carbon emission, it is cheaper. Perhaps as Lee said, some kind of green procurement policy will certainly help us, and we are looking towards that for having a green procurement policy. With this, I would like to thank all the delegates for their presence and having very good intervention from the floor side. My sincerest thanks to Deepa, who was full-time busy in taking notes and preparing the report for this. Thank you very much. With this, I conclude this.
Thank you to all our presenters for their insightful presentations. I will request our session chair to please present our speakers with mementos. We want to thank them for coming here. I request Mr. Pandey to please present a memento to Mr. Richard Yeo. A memento for Ali Pinch. A memento for Vijayta Bezam. And a memento for Ambika Behel. I would request Dr. Ravi Shekhar, Director CRI, to please come up on stage and present our session chair, Mr. R.K. Pandey, with the memento. Thank you all. I request you to please gather for a group photograph. Thank you to all our speakers. We will now take a 30-minute tea break. Tea, of course, is being served in the next to next hall. Do use this time to visit the expo. The expo, you can just exit the hall, turn to a little bit right, and you can see the expo. Plus, if you walk down the corridor on the left and take a turn and move a little further, there is an expo happening on that end of the hotel as well. Today is your last chance to see the exhibits at the expo, so make sure you do visit and see what all is in offer at the exhibition area. And remember to scan the QR code. You can get the summit souvenir, the presentations, all of them will be uploaded. So please scan the QR code and take in that information. I request all of you to please be in your seats by 11:30. We'll be starting with the next technical session, number 7. Our technical session very shortly. I request the presenters to please upload their presentations if they haven't done it so far. And if your friends are still sipping on their cup of tea, please ask them to come into the hall. We are going to start very shortly. We are going to start with the technical session 7, and the topic is making school zones safer, evidence-based approaches. Have you noticed a clear signage like school ahead, no horn or silent zones, or even speed bumps near schools? Have you seen any change in motorist behavior when they approach the vicinity of a school? I remember when I was in New York about 20 years ago, I was told to park many meters away from a school bus, which was stationary. I said, it's stationary, it's not moving. He said, no, if you park close to a school bus, you will get a ticket. So park away from a school bus. Now in India, while the rules are robust, the strict application and impact on safety will still depend on local implementation and enforcement efforts. So what approaches can work in Indian conditions to ensure that school zones are safe? This is what we'll discuss in our technical session 7. Please put your hands together and welcome on stage our session chair, Professor M. Parida, Professor IITR. Professor Manoranjan Parida is a former director of CSIR, Central Road Research Institute. He was the deputy director at IIT Roorkee before joining CSIR CRRI. At CRI, he played a crucial role in the development of steel slag road technology, AI-based road safety solutions, promotion of usage of industrial waste in road construction, and many others. So please give him a round of applause. He is on stage. And please welcome on stage our presenters for this session. Please welcome Prateek Nair. He will be giving a presentation on comprehensive 5E-based school road safety interventions. Please welcome on stage Bhavna Katoj. She'll be giving us a presentation on impact of low-cost school zone countermeasures on driver behavior. Please welcome Mr. Sanjay Kumar VS. He's going to be talking to us about towards safer roads, the role of pedestrian infrastructure in reducing crash severity. Please welcome Siddhartha Koramati. He'll be talking about new age integrated education engineering model for urban road safety. Please welcome B.B. Majumdar. He'll be talking about development of a systematic methodology for improving road safety on urban roads in India. And please welcome Mr. Akhilesh Srivastav. He'll be talking about school zone safety program of the IRF-IC. Please give a round of applause to all our speakers on stage. I would also like to tell you that the rapporteur for this session is Dr. Dhariti Kahali of CSIR CRRI. I would request Professor Parita to take this session forward.
So thank you very much for the introduction and setting the tone for this particular session, technical session 7, on making school zones safer, evidence-based approaches. I thought that this is going to be one of the best slots of the conference. In the morning, people might get delayed reaching the session. So this is immediately after coffee. Post-lunch, people might sleep. So you don't have any risk. People are all charged with a lot of energy. And we have 6 presentations, very focused presentations on school zone safety. We have a document of Indian Roads Congress, which is called IRC SP 32, which is Safer Commuting Schools. So before the document was revised, I'll let you know that what was there. So the entire responsibility of safety in school zones rested with the school children. They say that you have to do this, look left, look right. So most of us know which is part of the curriculum and then cross the road. So the entire tone of the document, it looks very unfortunate. In fact, the revision of SP 32 by Indian Road Congress, so I chaired that as chairman of committee H8 of IRC. After that, it has been revised. And then IRF India chapter has taken a lot of initiatives with respect to promoting school zone safety. Plus, we have total 6 speakers. So other than presentation by Sri Akhilesh Srivastavji, President IRF India chapter, so he's going to talk about the IRF-IC program. So that's a practical perspective, how do you implement the school zone safety? But then from research side, we have a presentation by Dr. Bandhan Bandhu Majumdar, then Dr. Siddharth, and Ms. Bhavna. We have presentation by Mr. Prateek Nair and Mr. Sanjay Kumar VS. So we have a mix of presentation from academics, from say research setup, and from practicing professional. I'm sure without taking much time, I'll invite the presenters as per the sequence of the design technical session. But request that please do not take more than 10 minutes so that at least we'll have some slot for the audience. So this is one particular session I am expecting. There are people with a lot of enthusiasm and deep concentration. So hopefully they will put questions to you. So if you can make some space for question answer, that will be really good. So with that, I'll now invite Mr. Prateek Nair. So in fact, I'll just... So Mr. Prateek Nair is the director of SCMS Group of Educational Institutes at Kochi, a very beautiful place in India. So it's also called as God's own country. And he's a committed advocate of road safety, teaches in management school, and he has a lot of interest that spans across education, public policy, mobility, and social impact. So with that, I invite Mr. Pratik for his presentation on a comprehensive 5E-based school road safety interventions, Surakshit Marg, and case study from Kerala. In fact, we'll have another case study also from Kerala after you. So thank you very much, and I welcome you for the presentation.
Okay. Good morning, everyone. So, my name is Pratik Nair, and I'm standing here to present our program, which we've been running for 2 years now, called Surakshit Marg. It is a comprehensive road safety program that we had designed for school children. So, let's go ahead. So Surakshit Marg program has become possible because of the partnership between two organizations. One, the Kootukaran Group, and the second, ourselves, which is the SEMS Group. Kootukaran Group is an organization that has been working for 85 years in the automotive sales industry, and they're one of the largest in India. And over a period of time, they have diversified into education and various other fields. SEMS Institute for Road Safety, SEMS Institute of Road Safety and Transportation comes under the SEMS Group of institutions, which is celebrating 50 years this year. And we have a wide legacy of education in business, engineering, architecture, polytechnic, and so on. Now, touching upon the SEMS Road Safety Institute, it was established in 2023, and in a span of 3 years, almost 3 years, we've been able to cover more than 3 lakh participants. We work a lot with the Kerala Motor Vehicle Department. We work with NATPAC, and we work with the district road safety authorities for 2 districts as well. Now, going on to the Surakshit Marg program, it is a school-centered road safety program that was designed by us for our CSR partner, that is Kootukaran Group. And we implemented that across 94 schools in year 1, and that was our phase 1 of the program. We have hence expanded it into phase 2, and which is ongoing right now, but I'll be speaking about phase 1 today. Now, within the span of the 1 year, we are able to create a massive impact. We have been trying to make this all evidence-based. And because of that, we've taken help from not just our organization, but any organization that works in road safety. Now, going forward, okay. So let's touch upon the 5 E's, and we start with education. So we took 2 teachers from each school, and that is, we started off with 100 schools plus, and then we brought it down to 94. And we started with 2 teachers from each school. We trained them on road safety because they didn't really know how to impart the knowledge of road safety to different students of different varying ages. And we are focusing on students from all the way from 1st standard till 12th standard. And so we had to create a different approach. We made this into a competition also, whereby each school is given 10,000 rupees initially with the help of our CSR partner. And depending on how well the funds were utilized, they were eligible to claim an additional 15,000 rupees. Now, given these constraints, we train the teachers on how to impart road safety in these schools. Over the period of phase 1, we had reached directly to 52,000 students. We had programs going all the way from the road safety skits by middle schoolers, emergency response training for the senior schoolers, road safety coloring competitions for the junior schoolers, and so on. Now, and when we started going to each school for this, we made all of these students road safety ambassadors for their own schools. Now, when you look at the engineering aspect of it, with the funds that we were able to give them, a lot of low-cost, high-impact school zone improvements were able to be implemented. For example, something as common as a convex mirror for when a vehicle is approaching the school or a school bus leaving the school to see if students are standing on the road. Road markings, a lot of them were not visible over the long period of time because most of the corridors in Kerala are high speed, high traffic. And we had brilliant help from IRF India chapter in helping us by providing the tool which we were able to use for the road safety audits. In all these schools, in all 94 schools, we were able to do the road safety audit. And in 47 of those, the low-cost specific implementations were done. The major infrastructural changes and gaps that were identified were given to the District Road Safety Authority. And with the help of the Motor Vehicle Department as well, we've been able to implement quite a few of them. Now, the enforcement part was something that we were having a little bit of an issue with because without the support of the Motor Vehicle Department of Kerala, we simply would not be able to enforce it. That is when a couple of teachers from a school came and said, why don't we use the students to, since they are ambassadors of the road safety initiative, why don't we use the students to do this? And with the help of the CII, Confederation of Indian Industry, YA chapters, we were able to bring out a Chota Cop program, whereby it was a report card program, where the students were grading how their parents were driving. If the parents were wearing seat belts, if they were wearing helmets, if the chin strap was on, if they were honking in a no-horn zone, and so on. And we were actually able to see that gradually, every parent that came to drop the students to school were following the rules. And later on, after repeated warnings by the students themselves, the Motor Vehicle Department did really step in and help enforce this to make it a regular thing. Now, going on to the emergency medical care, we realized that, especially in the state of Kerala, when an accident happens, the people who actually come running are not just random people who are passing by on the road. It is usually the Kirana store owners, the auto rickshaw drivers, and in Kerala, the headload workers. So these people really do come and try to help. And there were a lot of instances where lives were lost because they were not aware of how to properly handle an accident victim. So we took it upon ourselves, and with the help of the Indian Medical Association, we started training these stakeholders. In every school zone and at every intersection nearest to the school, we gave training to these responders. We did 73 first responders training, and all of them were already identified black spots. Across the state of Kerala, we have close to 700 identified black spots, and 74 of them we've been able to train people who are actually there throughout the day. Now, the evaluation part of it, as you know, road safety is a bit difficult to quantify other than accident and fatality numbers. And we took the help of a traffic psychologist with a master's in traffic psychology to help us prepare a questionnaire to see how the behavioral aspects were changing. It is true that you can't change somebody who is already driving, but so we decided to focus on the students who are going to start driving. And that's why we focus primarily on the senior schoolers and the undergraduate students of colleges. The findings were that we were able to really bring about quite an impact, and we were able to quantify it as well. When you look at the implementation, in a span of 1 year, in phase 1, we were able to touch 94 schools with 100% student participation. And in a span of 3 months, when the competition was happening, we were able to get 1,165 road safety activities done across these schools. And all this was in a 3-month implementation period. Right now, the phase 2 of this is going on. Another thing that we're very proud of is, since the program was launched, there have been no fatal accidents in any of these school zones as before. Another important fact is that the accidents that have happened in those areas were not fatal. There were a few serious ones, but the emergency medical care really did step in and help prepare the accident victim for emergency transport. We were able to increase the IRECS, that is the Inclusivity, Relevance, Effectiveness, Convergence, and Sustainability score to a significantly higher 4.82 out of 5 while this program was being implemented. The scale up. So we didn't want this to be a one-off program, and during this, when we were discussing it with our CSR partners, they were very positive towards the impact that we were bringing. And in phase 2, that is happening right now, we have expanded to 300 schools. And for the next 2 years together, we're planning on taking it to over 1,000 schools. And yeah, I think I'll just, shortness of time. So these are just a couple of photos. The students themselves took it upon themselves to make sure the teachers were spreading the word of road safety as well. And they designed drives where the teachers put posters of road safety and pedestrian crossings and all that on their vehicles. We had emergency medical care and the CPR training for students. We had role plays and skits performed on the road, not on the road, by the road, for the general public and awareness, with the help of the motor vehicle department as well. And for the young school children, especially the first to third and fourth standard, you don't really get a lot of impact by telling them about road safety. You tell them to walk on what side of the road, but so we decided to expand that into a coloring competition to get them more involved. And the more factual it is, the higher the marks. Now, I just want to touch upon one more thing. None of this would have been possible without our major supporters. And we have...
Mr. Nair, give me a wind up.
Time? Sorry, last slide. Yeah, and without the help of our supporters, we simply would not have been able to do it. And a big thank you for this opportunity to present our findings, and thank you.
Thank you very much for presenting the case study very nicely. It tells us that how to scale up the school zone safety program. So now we go for the next presentation, that is impact of low-cost school zone countermeasures on driver behavior and pedestrian safety, evidence from a 3-phase evaluation. The presentation is going to be made by Ms. Bhavna Katos, who is a doctoral student from Indian Institute of Technology, Roorkee. She works in the area of pedestrian safety with a particular focus on child safety in school zones. And her research focus on understanding pedestrian and traffic behavior in real-world traffic environments using various surrogate safety measures and data-driven road safety assessment approaches. And currently she is engaged in evaluating the short-term and long-term safety impacts of traffic control measures through before and after studies conducted in school zones. There are a couple of pilots, and I think it will be very wonderful and interesting to go through your presentation. So you can start now. So 10 minutes, Bhavna.
Good afternoon, everyone. So I'm going to present a part of my PhD work on impact of low-cost school zone countermeasures on driver behavior and pedestrian safety, evidence from a 3-phase evaluation. So road safety is a critical concern worldwide, especially in developing countries like India, where almost 43 children are observed to die in road accidents across the country, and around 7.4% of road accidents have been witnessed to occur near schools and other educational institutions as per Accident Deaths and Suicides report. So in these images, you can see that there is a very chaotic condition observed near during the school opening and closing periods, where the children, they have to cross the road without any supervision. There are lack of any traffic control devices. The traffic is unregulated, and a very high speed, they are expected to maneuver between the high-speed vehicles. And among all the vulnerable road users like the pedestrians and two-wheelers, the children are among the most vulnerable road users because of their small stature and their limited experience in the road crossing situations. Indian school zones often exhibit very unsafe operational conditions due to poor compliance, lack of traffic management. So in this study, we picked up some measures of effectiveness to evaluate the impact of low-cost school zone countermeasures recommended by IRC SP 32 2023, which is the recent school zone safety code. So based upon the guidelines, we observed the average speed at the entry and exit points near the school gate, the maximum speed, the average speed over the stretch, the yielding behavior, and conflict indicator post-encroachment time. So this work was done in 3 phases. So the data was collected before the implementation, then after implementation, which was done to examine the short-term safety effects, and then after 1 year, again, data was collected to examine the long-term safety effect. This is the study site. So before the implementation, thank you. Okay, it's not working. Yeah. Properly.
Point it that side.
सामने चल रहा है आप कुछ भी करना हो यहाँ से चेंज करो सब चेंज होते जाएगा
Okay. So here we can see the image, this image shows the before implementation condition at the study site. So the study site was at a school zone in Dehradun, Hillgrange Preparatory School. It is located near an urban road section. So the before condition at the school site shows a very chaotic situation. The data was collected using high resolution video cameras installed across the school entrance and also drones. The data was collected during the morning and afternoon school opening and closing periods. The duration was 7 to 9 p.m. in the morning and 12 to 2:30 p.m. in the afternoon, and the extraction was done using data from Sky software. The second image shows the after implementation situation at the school site. So as we can see, the overall road condition improved. The traffic management was quite smooth after the implementation. The obstructions which were present in between the road section, they were removed after the implementation. Different center line markings were implemented, transfer bar markings were implemented, and dynamic speed limit signs were, warning signs were also implemented. So these are all the signs that were implemented at the study site. So different school crossing ahead signs, school ahead sign, crossing ahead sign, and also the speed limit was reduced from 50 to 30 km per hour at the school section. Different informatory signs were also implemented, and different and also the existing pedestrian crossing, zebra crossing, which is black and white, this was replaced with the new zebra crossing suggested by IRC SP 32, that is the red and white crossing. So after implementation, these are the measure of effectiveness that were used to assess the situation, assess the improvement of the safety due to these implementations. So the average vehicle speed at the entry and exit points, these are shown in these 2 figures. So we can see that for both the morning and afternoon period, the speeds reduced gradually after the implementation. And first figure shows the spot speed at the entry point, and the second figure shows the speed at the exit point. So at both the entry and exit points, the speed reduced from the before to after 1 and after 2 period. The maximum speed at the entry and exit points, these were also observed to decrease in the after 2 period, but it showed a slight increase in the after 1 periods. This could be owed to the fact that after the removal of obstructions from the road near the school section, the traffic operation became quite smoother in the beginning. So that might have caused an increase in the maximum speed. Then 85th percentile speeds also showed a decrease in the after 1 and after 2 periods. We can see that it decreased after the implementation. Next, we observe the yielding behavior. So for that, we obtained the average vehicle speed over the entire section near the school zone, as well as the yielding behavior. So this also showed a decrease in the vehicle speeds. And the yielding behavior, it improved for both the morning and afternoon periods for motorcycle, car, and all the other vehicles as well. To validate the to validate that these improvement in speeds, they were due to the improvements, not by random variation. We performed statistical validation using ANOVA test, and here we can see that all the speeds and other measure of effectiveness, they showed a significant reduction, as we can see from the p-values. So that means that the reductions that we observed, they were due to the improvement in safety due to these implementations. Next, we utilized a conflict indicator, as we did not have any crash data near the school site. So we analyzed the pedestrian vehicle interactions in the school zone, and we obtained the conflicts based upon post-encroachment time, which provides the time gap between the two vehicles, two conflicting vehicles. So the number of conflicts, they showed a 82% reduction for the morning period across the after two, and for the afternoon periods, it showed a 43% reduction. This indicates that the high-risk pedestrian vehicle interactions, they were eliminated after the implementation, suggesting an improvement due to these implementations. Coming to the conclusion side, so the speed, we examined two parts. One was the speed and the other was the conflict. So the speed showed a reduction in maximum speeds. The 85 percentile speeds nearly halved, as well as the maximum speeds, they showed a 50% plus reduction in maximum speeds. The compliance increased by 12% as the drivers, they increased their yielding rates. The safety, the 82% conflicts dropped in the morning period, which indicates an increase in safety. Now, all of these were observed by implementing a very low-cost implementations in the school zone that shows that, such as signage, paints, and rumble strips. So adoption of these low-cost treatments is a very viable and high-impact strategy for resource-constrained settings to protect vulnerable road users in school zones. The improvements were also seen to be sustained and even deepened over time, proving the viability of these measures for long-term safety. The IRC's SP32 guidelines were found effective in moderating speeds and reducing conflicts, and thus we can say that these guidelines can be utilized for other similar site conditions and other school zones. However, we only selected a single school zone sites, and the data collection was done for a limited period of time. So in future, we are planning to access the safety of these implementations across varied urban contexts to generalize findings and validate consistency. I would like to acknowledge 3M Limited, India Limited to sponsor a project under which we have performed this work. And the extraction was done using data from Sky in our lab, Safe Trip Lab, Department of Civil Engineering, IIT Roorkee. Thank you.
Thank you very much, Bhavna. Sticking to time and a very lucid presentation. Thank you. So we'll take up questions after the end of all the presentations. You can take your seat. So with that, we now move to the third presentation, which is towards safer roads, the role of pedestrian infrastructure in reducing crash severity by Mr. Sanjay Kumar V.S., Jinumol Care, and Professor M.B. L.R. Anjanelu. So the paper is going to be presented by Mr. Sanjay Kumar V.S., who is a principal scientist from NATPAC, Government of Kerala. He's the farthest, he's the delegate from the farthest place, other than Tony Matthew of TRL. But it's good that we have a lot of participation from Kerala. So this is the second Kerala study which is going to be presented. And he has coordinated over 150 research-sponsored consultancy projects, which includes Safe Road to School initiative implemented across 100 schools in Kerala. And he's an accredited trainer with experience of delivering extensive capacity building program for police personnel, engineers, drivers, instructors, students, and the general public. So with that, I request you for that 10 minutes presentation. Thank you.
Thank you, Professor. It's good afternoon to all. So let me start with the topic of presentation is towards safer roads. Actually, I think I am an odd man out of here because all the speakers will be focusing on school zone safety, but I will be on an high level, like it is for the pedestrian safety. But anyway, all the school students are supposed to be pedestrians, so definitely mine will be applicable to them also. So, okay. I don't need to give you an introduction of the vulnerable road users and all those things, because we know that they are the most vulnerable, especially the pedestrians being what do you call the major, having the major share of victims across the world, as per the various statistics, that are various reports that has been published, keeping it as like globally or nationally or whatever standards you look into. But we definitely do have many standards and guidelines that has been developed. But how far it is being implemented, how far it is being followed by the authorities, that is something which we are addressing to in this particular topic. Some history. This is the first road crash fatality reported in the world. It is in the year 1896. The victim's name is Bridget Driscoll, and she was aged 44 and mother of 2 and other things. And, when we look into the actual reason for this particular accident, the so-called accident, it was reported to be overspeeding. At that time, the speed was reported to be 4 miles per hour, somewhere around 7 kilometers per hour. And the point to be noted here is that this happened in a circus ground or something like that, and she was a pedestrian. So the first crash victim across the globe by an automobile powered engine is a pedestrian. So that happened almost 130 years back, and so what I want to stress is that pedestrians have been at risk from the very start itself. This is a famous painting by Carl Jick, a Swedish painter, depicting how vulnerable are the road users in our urban environment. Just see like crossing a road is something like walking along a wooden plank over a gorge, or maybe something walking along the footpath. How severity is it? How the vulnerability is being faced by the pedestrians, that is depicted by this famous painting by Carl Jick. And yeah, of course, I would be showing some videos which will be disturbing to you, so viewer discretion is advised. And we have a lot of reasons like how these crashes are happening, maybe related to environment, maybe related to traffic, maybe related to driver, or whatever things. And this video is actually showing a state highway which is constructed using World Bank fund. And it is a two-lane highway, two-lane state highway, provided with good shoulders, good pavement, and everything else. And see an old man walking on the right side is being hit by a vehicle. So what precautions that we have made in this particular road to ensure the safety of the vulnerable road user, basically the pedestrian? That is what, the thing is that it is a World Bank funded project. So have we addressed the VRU in this video? That is what I would like you to just assess. And coming to some statistics, I don't want to explain all the statistics which you have been hearing from last day onwards. Because I'm coming from Kerala, a comparison of the total accidents and the pedestrian accidents with respect to the national level and the state level is depicted here. On an average, we all know that India has almost around 470,000 crashes happening, which are almost 180,000 fatalities around the year. And coming to our Kerala conditions, we are having almost 40,000 crashes per year, out of which 10% is contributing to fatalities. And again, within this, the pedestrians is accounting for 25%, around 25%. So our study period was from 2018 to 2022. In this 5-year itself, we had 5,150 pedestrian fatalities in Kerala roads. 5,150 pedestrian fatalities. And the share of pedestrian fatalities in Kerala is somewhere around 26%. In India, it is 16%, but definitely it is underreported, that we definitely know. And the scope of this particular paper is limited to 3 selected high-risk corridors in Kerala. And we have used the data from 2018, 19, and 22 because we have considered 20 and 21 data due to this COVID-related dips that has been shown. And the objective is to assess the infrastructure availability and to have a check with the crashes that has happened in these 3 corridors. The general methodology is like based upon the literatures. We have identified what are the various guidelines that are being followed, that are supposed to be followed. That I don't say it is being followed. That are supposed to be followed. What are the? Then we went on for a field survey in which the inventory data has been assessed, and we did the severity. We calculated the severity of these crashes based upon IRC 131, which is the code for black spot identification. And then we did a cross check between whether how this cross check, how the compliance level is matching with the CSI. The maps on the right side is showing the distribution of the pedestrian fatalities across the state. It's except the right-hand side, which is the mountainous areas. It is spread across the state. And next one is something like a corridor level approach, which is showing that again, corridors are also, we could segregate corridors where the pedestrians are found to be vulnerable. Some uniqueness which we have brought in here is that unlike the normal black spot approach that we do, or sport specific approach we do, here we went down for a corridor level approach because we clubbed the sport so that ultimately it will lead to a segment rather than a point specific thing. I'm not going to do how this was being developed due to the positive time, but anyway, we have demarcated pedestrian vulnerable corridors based upon fatalities, and we could identify 1,800 pedestrian vulnerable corridors in Kerala. And coming to our specific study corridors, we went in for 3 corridors only. One in Trivandrum, that is the southernmost part, the capital of Kerala. And second is in Ernakulam, almost the central part. And the third in Kannur, which is the northern part. The length of all these 3 segments is somewhere around, somewhere equal, like around 6,000 meters. And all of them are 4-lane divided highways. Even though I say divided, the presence of a median is there, but I don't know how, whether we can call it clearly as a median, because when I show you the data, we'll see that the width is something different than what we are supposed to follow. And coming to the severity of crashes, from the State Crime Records Bureau, we got the data, we segregated the data, we ultimately determined the severity of crashes of all these corridors. We put it together, and based upon the equation that is given in IRC 131, based on the weightages that is being given in IRC 131, we determined the crash severity index of each of these corridors. Yeah, as we can see, the first corridor that is having 39 crashes, witnessed 12 fatalities, but I mean, all these are pedestrians only, 12 fatalities, and the CSI, crash severity index, is coming to be 238. And the second corridor with 26 crashes had a CSI of 131, and the last one with the maximum number of crashes, 48, but since the number of fatalities is coming down, the CSI has come down to 207. Now, based upon the inventory, I will show you what are the geometric data and parameters of these corridors. The carriage width is somewhat okay. It is around 40 meters for all these 3 corridors. Coming to the median width, that is what I was telling, like the first corridor is having a 3-meter median. The second one is the median width is varying. I can't say whether it is a median, a divider we can say. And the third one is somewhere around 0.5 meters. So whether, again, it is a median or not, I don't know. And again, shoulder width is okay. And coming to footpath width, for the third one, there is no footpath available. And for the curb height, again, it is, you can see the differences between these things. And somewhere looking at the spacing of the crosswalks also, the second corridor, it is okay, because it is somewhat adhering to the standards that has been stipulated, but it is totally something very high compared to the standards. And presence of traffic calming measures, again, somewhat different. So ultimately, we can see that the corridor 2, which is having a maximum level of compliance, is having the maximum safety, we can say, or the least CSI. And unlike the other 3 corridors, other 2 corridors, which has got the least complaints, is showing more, what you call, more risk, we can say. So there is a strong relationship. We haven't gone into any statistical evidences or anything like that, because this is a part of a large project which is being carried out, and the other modeling part and other exercises are being carried out. Only thing is, we can, on a nutshell itself, we can see that the more is the complaints, the better is the safety that is being there. So we have the global plan of action for road safety, which is aiming at reducing the deaths and serious injuries by 50% by 2031. And see again this particular video, see a particular person, how he has been saved from his life. Actually, the global plan, we are supposed to follow the safe system approach because India is also a signatory of this resolution. And the main aim is something like they say, we are not supposed to say how the crash has happened, how the person has got injured. Here also how the person has got saved. That is what I should tell you. Yeah, sorry. See, here the only thing that saved his life is the presence of anything, presence of the slabs over the drains. That only saved his life. So otherwise, he or she would have definitely been killed. So at least that presence of a pedestrian, not a pedestrian footpath, I can say, presence of a slab saved his life. That's what I can say. So we know that humans are not robots. We process some data based upon the information, based upon the pressures, based on the economy, and everything else. And definitely the result is something like humans make mistakes. It's the first basic principle of safe system approach that we are supposed to follow. And the system is supposed to take care of these mistakes, right? We have to, yesterday also, we heard about the safe system approach. System is supposed to take care of the system. And as we engineers, as we policy makers, as we contractors, how are we going to take care of these mistakes? We know that it is a layered protection that we are bound to provide. And the role of these safe roads is the key, basic key in what you call tackling the mistakes that the road users do commit. And I don't want to know how many people need to be killed before I do something. So every delaying is going to kill more and more people. So investment or whatever things we do will make the system safer.
You can close now.
Yes, the last one. And one more video. I don't want this particular lady to be killed just because there was no proper footpath, there was no proper tackle payment, there was no proper race mark, even though she was walking on the left side, or even though that particular person was riding at high speeds. So mistakes are inevitable. We don't want more deaths and serious injuries. So 30 kilometers per hour and ride of everything is the limit that is just now school zone safety also being followed. And Vision Zero is achievable as proved by Helsinki. Akhil sir, you have also shared this one in LinkedIn. I also shared it. It is achievable because Helsinki has put up a 30-kilometer cap on the roads, and they have achieved 1 year without any roads or road deaths. So together we should work to have our roads safer. Thank you.
Thank you. Thank you very much, Mr. Sanjay Kumar. So we now move to the next presentation. So we have two presentations by our two of the speakers, Dr. Bandhan Bandhu Majumdar and Mr. Siddharth Koramati. So first presentation by Dr. Siddharth Koramati. So that's a new age integrated education engineering model for urban road safety, evidence and innovations from Sarvajana Foundation. So to introduce our speaker, Dr. Siddharth Koramati, he is currently working as a road safety specialist at Sarvajana Foundation. His research focused on improving road safety on urban roads. His work integrates cross-data analysis, low-cost engineering interventions, and evidence-based policy and planning approaches. Dr. Siddharth has led and contributed to multiple road safety initiatives, including pilot safety infrastructure projects, public awareness campaigns, and multi-stakeholder collaborations with government agencies, academia, and industry. His broader research interest includes traffic safety analysis, statistical modeling, then AI and ML applications in transportation and sustainable urban mobility. So with that, I request Dr. Siddharth, you can have 10 minutes for your presentation.
Sure, thank you, sir. Good afternoon, everyone. Thank you for this opportunity. So I'm representing today Sarvajana Foundation, a non-profit organization working on road safety space. So basically we have 3 initiatives, providing free knee surgeries to the poor, and STOP is a major, STOP is basically Society to Stop Prevent Accidents. So just want to introduce our board. It is founded by our Dr. A.V. Guruvareddy. He is a very famous orthopedician. In Asia, he is the second ranked doctor who has performed orthopedic surgeries. So first, we have 5 E's based on education, basically focusing specific to the children, and also in general. We have done several initiatives. The major one is Road Safety Championship for the schools, and this year we are also conducting for colleges. And also along with that, we are trying to partner with several stakeholders like magicians or hotels, so that wherever children goes, we can educate them, not just in schools, but also in the public spaces, recreative spaces where they go. So I'll just go one by one. And also engineering, we have done one pilot project where Wipro Circle is a major junction which had 12 deaths in the last 3 years. So it's majorly it's an IT hub, but there are a lot of schools and colleges also there. And also we have collaborated with the government, police, and also municipal corporations with the help of our CEO, who is an ex-IAS officer. Along that, we have done enforcement, emergency, and also the 5th is empowerment through advocacy. We have written several articles focusing on Good Samaritan law or other to increase fines, so that we can put some pressure on the government. So there are several activities we have done, like creating a digital family for the children so that they will be interested in watching. And also we have done an oath by P.V. Sindhu, the Olympic champion, so that children, she's a youth icon, so they can follow her oath taken from her father. And several other things we have done, which I'll show one by one. So this is the first engineering project we have done, Wipro Circle, which I said, which has 12 deaths from 21 to 24. So we have done several interventions like 10 to 12, which has a research backup, for example, 1 or 2% of reduction in deaths. And basically I want to highlight on such as peripheral transverse bars. So generally transverse bars are common in India, but peripheral transverse bars are very rare. So, and also some yellow carpet zones, so which are very new, and also from solar studs. So we had a problem while implementing this, because the contractors, even after telling them what is the peripheral transfer bar, because they're used to the transverse bars, they have just implemented transverse bars. So there are a few challenges, but we have achieved 67% reduction in fatal crashes when we compare with the last year. So these are just pictures of the interventions. Also, we have done a lot of road safety audits, and also we have done convergence meetings, not just audits, but we are meeting regularly with the GHMC, municipal corporation, the police, and taking their advice. And also we are confirming whether our interventions are right or wrong. So this model I want to focus, where we have almost 15 lakh schools. So reaching all the schools will be impossible in one's lifetime. So we have developed a centralized decentralized model where we can reach, if everyone adopts it. For example, if there are 15 lakh schools, there are 15 lakhs principal, obviously. So through the principal, we can reach the 1 crore teachers, and through the teachers, we have 20 crore, 6 crore students in India. So obviously, if we impart education through them, definitely they can teach the parents also, and thus we can reach 52 crore parents. So combining the students and parents, almost 50% of the population we can cover. So if they adopt this decentralized model, everybody, government or also private or NGOs, India-wide, so we can reach this population within no time. So this is the last time road safety championship which we conducted. So to encourage them, we have given some awards, and also by calling the ministers and also the top police DGP of the state. And we have given 1 lakh prize to the first winners. This year also we are conducting. So yeah, the oath which we have told, along with that oath, there is a quiz app also we have designed, and PV Sindhu has launched it. And with that, we have almost 15,000 people have participated. So these are basically traffic signs and road markings, along with some interesting questions. And we have given prizes as well. And this is the oath which we want to do, daughter to father. So basically, in India, people, there is a conception that don't listen to the law. So, but law needs some support. So we think that law can be supported with the help of the love. So definitely the parents will listen to their children, especially the daughters, because they are very precious. So if they take oath from their parents, they will follow the traffic rules. So this is the one of the model. And we also created this family mascot, so basically to entertain the children, also teach the road safety. We make videos and also cartoons. And this is the Yama. He's the Indian religious figure. So basically, he's a lord of death. So with him, we are trying to teach the children or also the parents that if they don't follow traffic rules, they might reach him. Yeah, so this is some pictures where children have done wonderful work. Almost 1,100 schools participated, like rallies and also doing some podcasts. Yeah, this Yamadharmaraji is going to all the schools, colleges, and also to the junctions. Yeah, so advocacy, which we have told, we have written several articles, like the on Good Samaritan law and is the traffic fines, because Telangana, Hyderabad has the least traffic fines on helmet. That is just 150 rupees, whereas other states has 1,000. So this does make some difference. And also we are doing some books, and also with the poets and also other artists. Yeah, another thing is we are erecting these huge sculptures, helmet sculptures. We know the importance of helmet, but just telling people forget. So we are erecting these huge sculptures along with the statistics, so that they can understand if there is no helmet, what's going to happen. So every day when the child goes with a parent to school, so they will see this and they will tell their parents to wear a helmet. So this is one of the things we are doing right now. Yeah, sorry. So we have planned for next year to reach 10,000 schools and also train 25,000 volunteers, along with that nominate 300 schools as the champions, and also gamify the quiz, which we are right now doing, and also launch a national school-based road safety curriculum, where right now it's not there. So we have to impart it in the road safety curriculum right from the school, from the first class. So along that, in emergency, we are trying to conduct eye testing for the truck drivers, because most of the truck drivers has a very poor vision, and we are trying to give a free eye checkup and treatment. Along that, building a statewide trauma care center, because our chairman is a doctor, so we are trying to focus on that as well. So to conclude, this engineering education, we can integrate them. So whatever we do in interventions near the school zone, we can also do these activities, so that we can educate the children along with the supporting these engineering measures. So we have achieved 60% crash reduction. We have structured the education, behavioral interventions, and also we have collaborated with the government and police officials. We are and most importantly, these are scalable and also cost effective, and these can be easily adopted. Also, we have tried to get the impact. So we are asking the schools to submit an impact report. So everybody is told that there is a 90% compliance before and after. For example, helmet. So helmet, now the parents used not to wear just 30 to 40%, now it's 90%. Similarly, we are trying to measure the impact as well. It is a little bit difficult to measure the impact, as already the speakers have said, but we are trying our best to measure the impact. I think that's it. Thank you.
So thank you very much. Sticking to time and very interesting presentation, and especially how to scale up, at least at state level. Other than Kerala, it's good to understand the Hyderabad story. Maybe the audience will have questions after all presentations are over. Thank you very much. So next presentation, again from the same group, led by Professor Bandhan Bandhu Majumdar. It's on development of a systematic methodology for improving road safety on urban roads in India. So to be presented by Professor Bandhan Bandhu Majumdar, who is currently Associate Professor at BITS Pilani Hyderabad campus. So they have a beautiful campus, and he jointly leads the Transport Research Innovation Analysis Laboratory trial at BITS Pilani. And his research interests include travel behavior analysis and choice modeling, non-motorized transport, sustainable transportation, and transportation safety. Dr. Majumdar has led the projects funded by various agencies: ICSSR Bikshit Bharat, DST SAR, MHRD Spark, GCRF UK, and ASCREEN Australia. He is the associate editor of KSC, Korean Society of Civil Engineering, Journal of Civil Engineering, Nature Scientific Reports, and co-chair of the track of Transportation Research Group, TCT C01. Theme C, that is transport planning, policy, economics, and project finance. He worked for some time at NIT Durgapur before shifting back to trial lab at BITS Pilani, Hyderabad. So I request you to make the presentation for 10 minutes. Thank you.
Yeah, thank you, sir. Thank you, and it's a wonderful opportunity to be here and among the august audience. I would like to present on a topic which is development of a systematic methodology for improving road safety. So again, once again, the theme of this particular session is on school zone safety, but I won't be presenting exactly on that, because my topic is in a broader topic, understanding how the safety can be improved across an urban city level. For Hyderabad, we have done that. Definitely at micro level for schools, similar kind of approach can be taken up. Okay. So this is again a part of a project funded by DST ACRB as part of Early Career Research Grant, which I received. And Dr. Siddharth, who just presented before, so he was my PhD student who actually worked on this particular project. So again, I will quickly skip some of the slides. So some basic slides which is we are there, I will describe and try to emphasize on what we have done on that. So we all know that road safety is a major concern, particularly in India, which is a developing country still, and the crash burden that is there, that's significantly higher. So as we can see, almost 480,000 road accidents as per the 23 data. Definitely the number has increased as days forward. So we are almost getting 474 daily accidents. And similarly, if I convert that to Hyderabad, we see that almost 3,000 accidents are happening, 335 deaths and 2,596 injuries. So numbers are quite concerning. so that needs to be addressed. For that purpose, we have developed a methodology which can take up both proactive as well as reactive measures together. So we have, if I look at the entire Hyderabad, there are several total 5 zones, total 60 police stations. But for our study, we have taken up top 20 police stations considering all 5 zones of the city. And we have taken the data for 3 years and did our analysis. So what we wanted to do, like very specifically wanted to identify what are the critical traffic fatality risk factors. Then we wanted to understand how they are affecting the crash prediction in future. Finally, we wanted to understand how we can actually evaluate the existing road and come up with some short-term measures or long-term measures. Of course, they have to be cost-effective. So for for identifying some of the crash identification factors, we have developed a methodological approach. I will just very briefly tell you. For the stated purpose, this side. Okay. Yeah. Acha, sorry. So basically, we wanted to understand, determine the risk factors. So we have taken up, there are different methods. So we have used some data mining methods as well as some machine learning models, some stochastic and deterministic approaches to actually find out what are the different factors. So I am not going to the entire theoretical setup. So we have found out that total of whatever the factors are there, both from the primary and secondary sources, can be classified into 6 segments, which can be very high risk, moderate, low risk, very low risk, and extremely low risk. And for each segment, we have identified what are the risk factors. So these factors, if properly identified and some measures can be taken up, that can actually lead to reduced road crashes in Hyderabad in general, India in specific. We have developed artificial neural network models and developed sensitivity analysis for that, which also helped us to identify and validate our results. Then we have again developed a crash prediction framework. Again, I'll just show you the result what we have done. We have developed safety performance functions. So this was one of the important contributions for our case, where urban area, so India, a lot of studies are there on rural area, where the safety performance function has been developed. We have developed it for urban area Hyderabad. So we have developed for mid-block, for signalized intersection, for unsignalized intersection. And for all these 3 cases, we have identified the key factors, such as, if you can see here, presence of vehicle curve, presence of traffic signs, which has got a positive effect. Similarly, we have developed the safety performance functions, which will help us to predict the future crashes with respect to traffic and built environment factors. Finally, we actually developed another method which will help us to identify the key safety factors. So now we all know this road safety audit is there, method is there, IRC SP 88 is there with us, which we can use for identifying locations, but we wanted to go little beyond. We of course took up the factors that is present there, the checklist given in the SP 88, particularly for the O&M stage, and also tried identifying what are the other factors that can play a role. Considering that, we have developed a unique condition index for mid-block, for signalized intersection, for unsignalized intersections. These indices we have used or applied in Hyderabad city roads, and we have found out their condition index and found out which are the most critical locations, and of course found out their fatal, non-fatal and total crashes. Then another interesting thing, this was one of the contributions I would say for this particular study, where we wanted to understand that for a particular type of crash, what could be a countermeasure. Of course, ideally we should do a before-after study and have like a cost-benefit ratio kind of thing. We do not have that at present for Indian condition. So what we have taken up, we have done a literature review for different types of crashes, like overspeed, like involving pedestrian, like if it is lost control or junction. We tried to identify what could be the possible countermeasures. And then we went to the experts and tried to rank them and getting their perception. And based on that, we have developed analytical hierarchy process, which is basically a pairwise comparison, which is a very interesting multi-criteria decision-making approach which can be taken up to find out the best solutions from the expert perspective. So we have done that, and like you can see, for overspeeding, we found out that installation of speed limit sign and speed cameras is the first one, followed by rumble strip. Followed by rumble strip, that's an important thing. So as far as concerned, this for urban section, the primary reason is primary could be this one, followed by this. So this can give a guideline to someone like how to take it up, and definitely it should be later on complemented by before-after study. So this was one of the major contribution, identifying countermeasures for various types. Here for an example, we have only shown for rear-end countermeasures. Apart from that, we have several other types of crashes which we can find out countermeasures for. So overall, that was the entire study where we wanted to understand what is the likelihood of crash, what are the factors that leads to this kind of crashes, how I can predict future crash, and what possible low-cost measures are there which can be used to reduce them. With this, I would like to end. We work in, I did not, for the limitation of time, I could not put a slide there. So I work at BITS Pilani Hyderabad campus, as Parida sir has told. So I work, we have our colleagues, Professor Shahu and Professor Sharma. We jointly lead the trial. There is a laboratory where we work on various road safety related, transportation planning and sustainability related projects. So please do reach to us and meet, write a mail or LinkedIn. We are very active in there. So it will be a pleasure to jointly work. Thank you.
Thank you very much, Bandhan. Although you said that it's not related to school zone safety, but the methods definitely can be applied in the context of school zone safety research. Many of the ideas, many of the framework can be certainly tried. So we'll wait for the audience questions. Thank you very much. So with that, we come to the last and very important presentation on school zone safety program of IRF India chapter. So it's to be presented by Sri Akhilesh Srivastav, who is president of IRF India chapter and ITS India. So he's an expert in road safety, intelligent transport system, and AI-led digital governance, safe driving scores, next generation tolling, and connected mobility ecosystems. He's a former NHI official. Many people would tag him to FASTag. In fact, yes, that's a very strong association. And the NHI data lake and large-scale highway digitization. He also directed the e-governance transformation of Uttarakhand, developing Apni Sarkar, India's first uniform civil code portal, and the country's first unified command and control center. Alumnus of IIT and Stanford, Mr. Srivastav is also best-selling author of digital construction management and building beyond infra, AI infrastructure, and his book on road safety is available. In fact, those who are interested can get copy of that. And he has many prestigious national and international awards. He worked very closely with AITD, World Bank, World Economic Forum, ITS Asia Pacific, 5GA to scale inclusive, intelligent and sustainability mobility systems across India and the global south. So with that, I request
Thank you
very
much, sir. Thank you very much, sir. And it's always my honor to share stage with you and the experts sitting over here. Most of us are connected on LinkedIn or some other platform. We keep on meeting. We all jointly try to solve a big social problem related to road safety, apart from many other things what we keep on doing. But this is a social menace, and as figures were shown, the first speaker, what Bhavna said, that 43 children die almost every day. This is a big number, and dying of a children because of road accident is totally a social responsibility. It's a shame on us because children, they are innocent. They do not know. They are just going to school based on the assurance given by their parents or the guardian or the teachers. And if we can't protect them, for a person who is driving fast, reckless and all, still we can find some alibi. Okay, that guy was himself or herself responsible for that. But what is the fault of young children? They just believed us and that's their fault. So it's a very emotionally touchy issue. Anyway, coming quickly to what we are doing at IRF, we came out of the theory or the statistics. We wanted to do something actually on the ground. How can we save make the school zones safer? Because as per data which Bhavna just showed, around 7.8% fatalities takes place of the children in the vicinity of a school. So if school can be made, because these are the identified spots. We know there are finite number of schools. If these schools are made safe, at least probability of accident or the fatality near a school can be saved. That's in our hand to do. How can we quickly do it? And that is what IRF came forward with a digital platform and with the help of digitizing the process defined in the IRC SP32. Just brief highlights of this, and I'm fortunate that today's session chair is also the person who drafted this SP32 guidelines, Professor Parida. That time, since then we decided, we developed a lot of guidelines and codes. There are many road safety guidelines, road audit guidelines, so many things are already there, IRC, the government. But these audit reports are so voluminous, it's difficult for even engineers to understand. Let me be very frank. People just read the conclusion para and hardly anybody goes much deeper, except to make the DPRs for rectification and all. So if it is left to certain people only, then we cannot solve a social problem. Social problem can be solved when the society gets involved. And in the name for the children, I'm sure everybody will come forward because parents are the first responders to them. But parents may not be an engineer, so how they are going to read that voluminous or highly technical zone safety audit? So we came forward with an idea that we will be doing two things. Firstly, digitizing the process of school zone safety audit, converting the guidelines which are mentioned there into a portal-based questionnaires so that it can be done very quickly and with the help of digital tools. Second, what we try to do, make it in a very simple, lucid way, when even a parent whose child is going to school may not be even literate also, but by color they can understand the school where my child is going is showing green or showing red. Red means is a danger, so I should be cautious when I'm sending my child over there. Or at least they can raise their voice at appropriate platform, forums, or anywhere, so that administration takes note of that, and more the voice, the administration quickly resolves it. So with these two aims we did, and we were fortunate that this portal was very well taken. It was launched by none other than Honorable Minister Gadkari sir in one of our events. This was very well taken by Ministry of Education when we presented to Secretary, Ministry of Education. He immediately the ministry gave us a list of 50 schools in 5 states, and they asked us to do the pilot on that. We completed that. He also gave, after completion of that pilot, list of 1.5 lakh schools spread throughout the country, where we can do it in 2 to 3 years' time. That was the regarding portal. But who are going to do the audit on the portal? Because there is a slight change in the methodology. So we decided that let's create a group or category of the skilled people who can do this. A new kind of job created for civil engineers, young civil engineers, or even diploma in the civil engineers with few years of experience. They can be created as another experts. Because school zone are finite, they may not be the very skilled road safety engineer may not find it a very lucrative job. So why not involve the other people also? So with this, we created a online course also. This is a very simple course, 8 modules online. 1 is a live course and 3rd is a practical, where those people go and they complete the process of the auditing. And once they do it, they are given a certificate and certified auditors for the school zone. This way, we are trying to create a bunch of experts countrywide. We are getting a very good response. Many states, like yesterday, sir, I was talking to Assam government. They asked us to train 50 master trainers. Similarly, other states, we are also in touch with Kerala and other government as well, Karnataka. We will be creating master trainer, and then those master trainers will create further. So ecosystem will be developed with the portal, with the people or experts on the ground and things. Now, very quickly coming to just inside this, I already explained our discussion, what was the outcome of the, a curiosity maybe with you all, what was the sir audit report said. So this is the audit report very quickly. You can see in Assam, except one school, because if you look at the score, the 80 plus score are categorized as safe, and 0-20 is dangerous, 21 to 40 are unsafe, and then 40 to 60 are risky. Just look at the Assam. Only one school can be in a zone of the rest are all unsafe and dangerous. Same goes with the Bihar, except one school in 40s only, rest are all unsafe. Karnataka, slightly better. I must say, some are above, majority are, many of them are above 40. One was good with the score of 70. UP, same scenario like other states, Tamil Nadu this. So what does this actually indicate? It's same thing what we had been just talking, and why the fatalities are so high. The schools are literally unsafe, zones are unsafe. We must do something to immediately identify. So these are the key recommendations which we submitted to the government, and we are, through this forum, we are also trying to highlight and build more pressure to we got 1.5 million schools, 15 lakh schools in the country. 10% has been given to us by Ministry of Education. There are still more than 3 lakh schools on the national highways itself. We are approaching to NHAI, MORTH, to at least give those permissions. This can be audited by people, and their scores are known. At least rectifications come next. Disease is diagnosed. We know I am having high blood sugar, then I avoid sweet. Similarly, if the parents and people know that the school is unsafe, at least they will be cautious. They will not leave their child 1 kilometer ahead and chale jao, and that poor child doesn't come back. So that can be done. So that is what we are trying to do, and that's the key recommendations we have given. Thank you very much, and I hope I kept in time. Sir.
No,
thank you.
Yeah, you are very much well in time, and thank you very much for very lucidly sharing the details of IRF India chapter school zone safety program. So with that, I'm opening it for the audience for few questions, answers, but maybe 2 to 3 questions. So, yeah, Abhishek Chakraborty, please be very, very brief. You need to get a mic. Briefly introduce yourself and also identify the question is for whom.
Yes.
For who is the speaker.
Hello, I am Abhishek Chakraborty, scientist at CSIR CRRI. It was a very wonderful session. Congratulate all the speakers. I have a small doubt to Ms. Bhavna. So, in your work, did you selected the school based on any suggestion from PWD or in collaboration with any government agency? Why I'm saying, because you also showed a graph that average speed, spot speed, before implementation was less than 25, something to 18, 20, something like that. So if it is already under the safer zone as per the IRC guideline, then means why you selected that school for demonstrating your work?
Actually, we conducted some preliminary surveys near the school site. We observed the situation during morning school drop-off and the afternoon pickup period, and it was seen that it was very chaotic environment at those times. Also, we had some consultations with the municipality there in Dehradun, and that school has been identified as a very problematic situation.
So is there any crash history? Means it was no.
Yeah, so let me add on that. See, the speed limit being less than 30 or 25 is not a criteria to declare a school zone safe. There are many more parameters, and that's what she checked, that there are no signages, there may not be any separate parking drop-off, drop-in zone. There is many more challenges. That is what is in IRC 32 mentions. So many of those were not there.
Kapila sir.
I have one suggestion, that you should all get together, combine your programs, settle on one IRC specific what you want to do, and then do it together rather than doing in bits and pieces at various places. Let's have a combined effort taken across the country.
Yeah. So yeah, that's going to be very, very useful. Maybe IRF India chapter can think of one day focused workshop on school zone safety. So at least that can bring focused attention. But very well taken, sir, your suggestion. Sub-national level program, that's very comprehensive. Any other? Yeah, Mr. Hamdi.
Yeah, actually, this section was one of the most interesting for me. And you have the most fatalities in the world, and you are taking care of this issue. Actually, something is missing, and you have so many initiatives and foundations. They are taking care of this issue. Actually, this issue is this problem is problem of the governments. But you are helping the governments. For example, in Finland, one presenter said that last year Finland had zero fatalities because the infrastructure is there and the rules are there, and the most important is that you can have millions of rules. If you don't follow the rules, then it doesn't help you. And is there any problem that you have a lot of engineering companies, good engineers? Yesterday, one professor said that you are the factor of good engineers here in India. You are producing a lot of engineers, distributing to the world. And can't we, I mean, I am also 49% Indian, as I said. Can't we do something that we go to governments, say, at least this is a financial issue to finalize all the infrastructure like in Europe, in Finland, but at least we do the design work of this. Then we know, we put in a row, this is very urgent, this we can do this year, according to a 5 years, 10 years plan, that we finalize it within 10 years. You can't do it. You can talk in all congresses, but you can't do anything. We have to do something. To do something, we need money and initiative. The initiative from the foundations and from the public is there, but the initiative from the government side is missing, I guess. There must be a plan to finalize the infrastructure. In the cities, perhaps with the municipalities, I don't know the system, how it works here. In the cities, with the municipalities, and in other urban areas with the other governmental organization. This is my suggestion, but I am very surprised and I am proud that you have established so many initiatives and foundations to help the people that they are, because especially the kids, they are the future of a nation.
Correct.
I mean, in China, they said only one child. Now they are saying more, because the people are getting old. In India, you don't have the problem, but
I guess in 5 to 10 years, you will have the same problem like in Europe. There, the population is going down, and with robots, we can't live. Thank you.
Thank you very much. I mean, you are, as you said, 49% Indian, and we consider you 51% Indian because you always talk very positive and good things, give good suggestions as well. Thanks. And in fact, you rightly said so, it's a government job. But government is who? We are all actually represent some or other form to the government. So we are trying to do it as a society also. And of course, push has to be there. Government, like they gave us a list of 1.5 lakh. But then and then we approached Mr. Kapila and we went to Ministry of Road Transport. We tried to convince them that at least on highways, give us we have the list of school, allow us to do this audit and just give the school status. I mean, nothing more, but slowly things are building up, sir.
I have one good news for all those who are here. The Supreme Court committee has called us on the 11th of this month to to issue a directive to all states to address this issue. I am confident once this directive goes from the Supreme Court Committee on Road Safety, all states will start working on it.
Thank you, sir. Any last question? Anybody wishes one voucher, one last voucher? Okay. So we have Mr. Sinha from Niti Aayog, advisor to Niti Aayog. Anyone, Tony, any question from you? Huh? Yeah. So, the finishing comment.
They're already doing a lot of work in
You want a finishing comment or a question? It's a question, right? So, I was thinking about this. Prateek has presented about 75 school interventions, which then recorded no accidents. Yeah? If you can elaborate a bit more on what specifically contributed to that scenario, like for everybody's enlightenment here. So whether it was a behavior change or whether it was an infrastructure change, what contributed, that change?
Excuse me. Not just one, but there were a few interventions. For example, we made sure that with the help of the enforcement, we made sure that anybody coming to campus was only allowed to enter campus, whether it is a parent, teacher, whoever it is, were only allowed to enter campus if they were wearing their helmets, for example. Okay, so that eliminated a lot of the easy intervention that we could have done a long time ago. The second was the emergency medical care. I mentioned that there were no fatal accidents. So there were small accidents, but nothing major, nothing that led to death. Another one was road infrastructure. The small examples of, in fact, one of the schools that we had intervened in had an accident whereby a vehicle going out of the school hit one of the students crossing. So we put the convex mirrors, which really helped anybody going out of the campus to see on both sides if anybody's standing on either side. These are some of the interventions that we did. Naming all of them would be a bit, yeah. But yeah, I hope I covered the question. Thank you.
So thank you very much. With that, we come to close of the session. I am really thankful to IRF India chapter for this opportunity to chair this session on school zone safety, specifically because I chaired the H8 committee for the modification and development of school zone safety document. And I'm sure I wish that we know more and more about the challenges, issues of the document, the kind of revisions which are required. In the process of implementation, definitely we can understand that what challenges, what research questions need to be addressed, and as suggested by the audience, definitely IRF India chapter is continuously exploring opportunities to work with government, with various, not just government of India, state governments to ensure implementation of these ideas of school zone safety. And I would like to thank all my distinguished speakers, those who are on the dais, which covered. You had people from NGO, academics, from research, and from policy making. So that's how they could make the session very interesting. And thanks to the beautiful audience and their interventions with respect to the session. So thank you all. With that, I hand over to the session coordinator for closing of this particular technical session.
Please give a round of applause to all our speakers on stage and to our session chair for summarizing the very interesting presentations that happened in this session. I would request our session chair to please present the speakers with mementos. We want to thank them for sharing their knowledge with the audience. I request you to present a memento to Pratik Nair. A memento for Bhavna Katoj. A memento for Sanjay Kumar. All right. One for Mr. Siddhartha Koramati. A memento for Mr. B.B. Majumdar. A memento for Dr. Dhariti Kahali, who's the rapporteur of this session. I would request Mr. Hamdi Aydin from Turkey to please come up on stage and present our session chair, Professor Parida, with a memento. Thank you so much, sir, for sharing this discussion. I request all of you to please gather for a group photograph. I request Dr. Kahali to please come up on stage for a group photograph. Please give them a round of applause. Right, it is time for a break, and I request all of you to please visit the exhibition area for the next 15-20 minutes, because lunch will only be served later, around 1:30 or later. So please use this time to visit the expo, go to the booths, ask your questions about whatever service or product is being offered, and please join us for the plenary session, which will happen around 2:10 in the other hall, which is hall number 2. So that is the place to head post lunch for our plenary session. We'll see you soon.